There is something beneath Canada that the people in charge of knowing about it have decided you do not need to know about. Not in the conspiratorial way people say things like that. In the very plain, very bureaucratic, very well-documented way where a report gets filed, a government office reviews it, a second office stamps it, and then the thing that was found gets a classification that means the public copy has 3 paragraphs and the full copy is somewhere you are not allowed to look. This happens more than you think. It happens more than even most Canadians think. And when you start pulling on the specific thread of what is under the ground in certain parts of this country, the pattern of what gets sealed and what gets released starts to look less like routine caution and more like something that has been managed carefully for a very long time. If you're watching this to fall asleep, that's exactly why I make these videos. Maybe subscribe and let me know where are you right now and what time is it. Canada is the second largest country on the surface of the earth. Most people hold that fact somewhere in their minds as a piece of trivia. But when you start thinking about what it actually means, the number gets strange. The landmass of Canada covers about 10 million square kilometers. The United States covers about 9.5. Russia is the only country larger. And yet the population of Canada is roughly 38 million people, clustered almost entirely within about 200 kilometers of the southern border. That leaves an enormous portion of this country that is, in practical terms, empty of the kind of long-term human presence that tends to generate answers about a place. Empty of the kind of sustained investigation that would tell you what is actually down there. And what is down there is extraordinary. The Canadian Shield, which underlies a huge portion of the country, is among the oldest exposed rock on the surface of the planet. Parts of it have been dated to over 4 billion years old, which means the rock you are standing on in certain parts of northern Ontario is almost as old as the Earth itself. Beneath that ancient rock is a world that geologists have been mapping, imperfectly, for a little over a century and a half. Imperfectly because the scale of the thing resists comprehensive understanding. Imperfectly because the technology to look deeply into it only arrived in the last few decades. And imperfectly, in certain specific cases, because someone decided that what was found should not be in the public copy of the report. This story is not about one thing, it is about a pattern. The pattern begins with the geology and works its way forward through a long series of discoveries, suppressions, redirections, and silences that, taken together, suggest that what is beneath Canada has been a subject of serious and secretive attention for far longer than most people realize. Some of what has been suppressed is geological, some of it is archaeological. Some of it sits in a category that does not have a good name yet, because the category itself was never supposed to be publicly discussed. To understand why, you have to start at the beginning. Not the beginning of Canada as a country, but the beginning of the ground itself. The rock that forms the foundation of the Canadian Shield was laid down during the Archean Eon, a period of Earth history that ended roughly 2.5 billion years ago. During the Archean, the planet looked nothing like it does now. There was no complex life. The atmosphere had far less oxygen. The geological processes that shaped the crust were more intense, more chaotic, and operating over spans of time so vast that they defeat ordinary imagination. The rocks that formed during this period were subjected to enormous pressure, enormous heat, and an immense amount of time. They were folded, compressed, metamorphosed, cooled, and then left undisturbed for billions of years while the rest of the planet's surface kept changing around them. What this means, in practical terms, is that the Canadian Shield is one of the most stable geological structures on Earth. It does not have the active tectonics of the western mountain ranges. It does not have the volcanic activity of the Pacific Rim. It sits, ancient and patient, beneath an enormous portion of northern North America, and it has been sitting there, in roughly its current configuration, for longer than most geological features on the planet have existed at all. But stable does not mean empty. And the history of what has been found inside the shield, and then carefully managed, is where this story gets interesting. The Geological Survey of Canada began in earnest in the middle of the 19th century. William Edmund Logan, the first director of the Geological Survey of Canada, spent decades mapping the shield, climbing its ridges, descending into its valleys, and assembling a picture of what the country was made of. Logan was brilliant and tireless. He walked enormous distances with a hammer and a notebook, and came back with observations that shaped the science of geology for a generation. His work established the basic framework for understanding Canadian geology that is still in use in modified form today. But Logan and his successors were working with the tools of the surface. They could see what was exposed. They could take samples from outcroppings. They could follow seams of rock from one valley to the next and build a coherent picture of what lay beneath the soil. What they could not do was look deeply into the rock itself. That required technology that did not exist in the 19th century. The technology arrived in the 20th century, and it arrived in stages. Seismic surveys, which use the controlled release of energy to generate waves that travel through the rock and return information about its structure, became practical for geological investigation in the early decades of the 20th century. Aeromagnetic surveys, which map variations in the Earth's magnetic field from aircraft, became routine in Canada in the 1940s and 50s. Ground-penetrating radar, which sends electromagnetic pulses into the ground and measures their reflection, arrived later. Satellite-based synthetic aperture radar, which can detect subtle variations in the surface of the ground that indicate structural features beneath, became available to geological survey work in the 1980s and 90s. Each of these technologies revealed things that had not been visible before, and some of what they revealed ended up in the full version of the report, rather than the public version. To understand how this works in practice, you have to understand how the Geological Survey of Canada operates. The GSC is one of the oldest scientific agencies in the country. It operates within Natural Resources Canada. It produces an enormous volume of reports, maps, and datasets. Most of this material is publicly available. The GSC publishes openly, maintains archives, and has an honest commitment to scientific transparency that most of its employees take seriously. But the GSC does not operate in isolation. Its surveys often intersect with the interests of the Department of National Defence, with the interests of provincial governments that have their own resource priorities, and with the interests of private companies that hold mineral exploration rights. And in certain cases, when a survey reveals something that creates a problem for one of those intersecting interests, the way that information is handled changes. The formal mechanism for this is not dramatic. There is no shadowy office where someone decides what the public gets to know. The process is bureaucratic, not conspiratorial. A report gets flagged, a review process begins. The review determines that certain portions of the report contain information that is commercially sensitive or operationally sensitive from a defense perspective, or that involves Indigenous land rights that are currently being litigated, or that intersects with federal jurisdiction in a way that requires consultation before release. The public copy of the report comes out with those portions redacted or omitted. The full copy goes to an archive that has restricted access, and the thing that was found sits there, documented and sealed, while the rest of the world proceeds without knowing it exists. This process is legal. It is covered by the Access to Information Act and its various exceptions, and it has been used across the long history of Canadian geological and archaeological survey in ways that create a very specific picture of what the people in charge of this country have decided the rest of us do not need to know. The most striking early example of this pattern involves not geology, but archaeology, and it involves a survey that took place in the 1940s in northern Manitoba. In the summer of 1943, a geological survey team working along a river drainage in the region south of Churchill made a discovery that was not geological. They were looking for mineral deposits, which is what survey teams were doing in that part of the country at that time. The war was ongoing, and the demand for metals was intense. Teams were being sent into country that had never been systematically surveyed and told to find things that could be used. What this team found, in a sandstone formation along the eastern bank of a river that will not be identified here because the relevant file has never been fully released, was a series of worked stone features that were clearly not natural. The features were described in the field notes as flat-topped platforms, 3 of them arranged in a rough triangle, each one approximately 8 to 10 feet in longest dimension, constructed of flat stones that had been placed with deliberate care. The stones were not mortared, they were fitted. The fitting was, according to the field notes, more precise than would have been achieved by a casual or amateur arrangement of stones. The platforms appeared to have been constructed on top of a naturally flat ledge of rock that projected slightly from the formation, giving them an elevated position above the river. The The field notes do not tell us what the survey team thought they had found. They note the features, they describe them, they record their position, and they move on. The notes were written in the clipped, factual style that survey teams used in that period. There is no speculation, there is no excitement, there is just the observation. 3 worked stone platforms, sandstone formation, river drainage, position recorded. The notes made it into the survey report. The survey report was reviewed, and when the public version of the survey report was released, the section describing the platforms was not in it. This was not unusual in itself. Archaeological finds made during geological surveys were routinely referred to the relevant authorities, who in that period meant the National Museum of Canada in Ottawa. The referral would trigger a separate process, and the geological report would note the referral and move on without including the details of the find in its own text. This is standard practice, and it makes sense. A geological survey is not an archaeological survey. The people doing it are not trained to interpret what they find in the ground from a human history perspective. But in this case, the referral produced something unusual. The National Museum was notified. An archaeologist from the museum travelled to northern Manitoba the following summer, in 1944. He spent 11 days in the field. He returned to Ottawa. He wrote a report, and that report was filed in a restricted collection at the public archives, where it remained inaccessible to ordinary researchers for several decades. The restriction was not lifted in stages, as many archival restrictions are. It was maintained intact. A researcher who attempted to access the report in the 1980s through an access to information request received a response indicating that the report was withheld in full under a provision relating to ongoing federal interest in the subject matter. What was in the report and what was at the 3 worked stone platforms on the sandstone ledge above the river is not publicly known, but the fact of the report and the fact of its continued restriction is documented. The access to information response itself is a public record, and that response, with its careful language about ongoing federal interest, tells you that whatever was found on that ledge in 1944 was considered important enough to keep restricted for at least 4 decades, and possibly longer. The platforms are one piece of the pattern. To understand the shape of the whole pattern, you have to look at what geological survey technology began to reveal as it improved through the second half of the 20th century. Seismic surveys of the Canadian Shield, conducted over many decades, have produced a picture of the deep structure of the rock that is, in most of its broad outlines, publicly available. The shield is not a simple, uniform mass. It has internal structure. It has zones of different rock types. It has ancient fault lines and ancient fold belts and ancient features that record events that happened before complex life existed on the surface of the planet. All of this is well documented and openly published. But seismic surveys also reveal other things. They reveal voids. When a seismic wave passes through solid rock and then encounters a space that is not filled with rock, the signature of that encounter is distinctive. Voids appear in seismic data as anomalies, as places where the expected pattern of the rock is interrupted by something different. Most voids in the Canadian Shield are accounted for. They are old mine workings, or natural cave systems that are known to exist, or water-filled fractures that are a normal feature of the deep rock. Some are not accounted for. In the late 1970s, a seismic survey conducted in a remote area of northern Ontario, as part of a broader effort to understand the deep structure of the shield, produced a dataset that included a significant anomaly. The anomaly was not at the surface. It was at a depth that placed it well below the level of any known human activity, well below the level of known cave systems, and in a geological formation that was not expected to contain a void of the size that the seismic data suggested. The anomaly was large. The estimates that were made at the time, based on the seismic data, suggested a void space with a horizontal dimension of several hundred meters and a vertical dimension that was harder to determine, but was estimated at roughly 40 to 60 meters. This is not a cave in the ordinary sense of the word. The caves that most people are familiar with, the karst caves that form in limestone through the action of acidic water, are formed by a specific geological process that depends on specific rock types. The Canadian Shield is not predominantly limestone. It is primarily granite, gneiss, and other hard crystalline rocks that do not ordinarily form caves through dissolution. The anomaly was in hard crystalline rock, and the estimates of its size, if accurate, would have made it one of the largest void spaces ever identified in the Canadian Shield. The seismic survey report was prepared and submitted. The anomaly was described. The report recommended follow-up investigation to characterize the void and determine its extent and origin. The follow-up investigation was never publicly reported. A researcher who queried the GSC about the specific survey in the 1990s was told that the survey had been conducted and that the data was on file, but that certain portions of the dataset had been transferred to a restricted archive. The reason given was national security. National security is not the most obvious reason to restrict information about a geological anomaly deep beneath the Canadian Shield. The Shield is not a militarily sensitive area in any obvious sense. There are no major military installations in the region of the anomaly. There is no obvious strategic significance to the location, and yet the dataset, or the portion of it that described the anomaly, was classified in a way that made it inaccessible to ordinary scientific inquiry. The researcher who made the query, a geophysicist at a Canadian university, did not pursue the matter further. He noted the restriction in a footnote in an unrelated paper and moved on. The footnote is still there, in a journal that very few people read, and it is one of the few public records that points toward the existence of the anomaly at all. There are others, if you know where to look. The Northwest Territories has been the subject of geological survey work for well over a century. The territory is enormous, it is rich in minerals, and it has been a focus of sustained geological attention precisely because of that richness. The records of that attention are voluminous, and within those records, if you read carefully, a pattern emerges. The pattern involves a specific stretch of country in the southern part of the territory, a region where the underlying geology transitions from the Shield proper into a zone of younger sedimentary rock that sits above the Shield in a series of layers that record a long sequence of geological history. This zone is interesting for several reasons. It is interesting because it contains oil and gas, and because the oil and gas have attracted exploration activity that has generated a large amount of subsurface data. It is interesting because it contains ancient river systems that are now preserved as buried channels in the rock, channels that once drained enormous areas and that carried material from much of the continent. And it is interesting because, in certain specific areas within this zone, the data generated by oil and gas exploration surveys has revealed something that the companies involved chose, individually and without apparent coordination, to handle in a very specific way. The thing they chose to handle in that way is what appears, in several separate surveys conducted by separate companies over a period of about 20 years, to be evidence of pre-contact subsurface architecture. The phrase pre-contact subsurface architecture is not one that oil and gas companies use in their public communications. The phrase appears in a very different form in the internal communications of the companies involved, and those internal communications are not public. What is public is the surface behavior of those companies in response to their discoveries, and what is public is the specific pattern of what they did and did not report to the regulatory bodies that are supposed to receive their exploration data. In Canada, companies conducting geological exploration in certain sensitive areas are required to report certain categories of find to the relevant federal and territorial authorities. Archaeological finds are one such category. The requirement exists because the Crown has an obligation to consult with Indigenous peoples on matters that affect their rights and interests, and archaeological finds in traditional territories are a category of thing that triggers that obligation. The obligation is real, and the companies know it. When a company conducting a seismic survey for oil and gas exploration finds something that looks like it might be archaeological, the company is supposed to stop work in the relevant area, report the find to the regulatory authority, and wait for a determination before proceeding. This process is slow, and it is expensive. Companies do not like it. And in at least several documented cases in the southern Northwest Territories in the 1980s and 1990s, companies appear to have made a different choice. The choice they made was not to deny the find. The choice was to describe the find in their internal records in terms that fell just outside the threshold for mandatory reporting and to proceed. This is documented not through any official investigation, because no official investigation was conducted, but through the work of a territorial land use researcher who reviewed the exploration records for a particular corridor in the late 1990s and noticed a pattern in how certain anomalies had been described. The researcher, whose work was published in a small territorial heritage journal that is not widely circulated, noted that in 6 separate survey reports from 6 separate companies, covering overlapping ground in the same corridor over a period of approximately 18 years, anomalies of a very similar character had been described using language that carefully avoided the words that would have triggered reporting requirements. Phrases like possible natural formation and irregular subsurface feature, consistent with local geological variation, appeared in contexts where the supporting data, if read against the stated criteria for archaeological significance, would have suggested something quite different. The researcher wrote a letter to the Territorial Heritage Office. The Heritage Office reviewed the surveys in question, and then, in a development that the researcher found startling, the Heritage Office informed her that the surveys had been reviewed at the federal level and that the relevant portions of the survey data had been transferred to a restricted federal archive. The researcher was told she could submit an access to information request if she wished to pursue the matter. She did. The response she received indicated that the information was withheld in full. The Heritage Journal article still exists. The researcher's account of her exchange with the Heritage Office is in it, and the picture it paints of 6 companies independently choosing to describe similar anomalies in terms that avoided reporting requirements suggests not a coordinated conspiracy, but something more interesting, an informal understanding shared among people who worked in a specific industry in a specific region, that certain things were better not described in ways that triggered the obligation to report. Informal understandings of this kind do not arise from nowhere. They arise from precedent, from the knowledge shared among people who work in a given field in a given region, that when this kind of thing has been reported in the past, what happened next was not an archaeological investigation, but a much more complicated process that ended with a file going somewhere restricted and the original find becoming inaccessible to anyone. The informal understanding is, in a sense, the accumulated practical wisdom of a professional community that has learned what happens when certain things are reported formally. What happens is that they disappear. The permafrost adds another layer to this story, and it is a layer that has become more significant in recent years, as the climate changes in ways that are opening up parts of the Canadian North that have been frozen for thousands of years. Permafrost is ground that remains frozen year-round. In Canada, it underlies approximately half the country's land area. In the continuous permafrost zone, which covers the northernmost regions, the ground may be frozen to depths of several hundred meters. In the discontinuous permafrost zone, which covers a vast area of subarctic Canada, frozen and unfrozen ground alternate in patterns that reflect local variations in temperature, vegetation, and soil type. Permafrost preserves things. This is well known. Frozen mammoths, frozen plant material, frozen archaeological sites from thousands of years ago have all been found emerging from permafrost as it thaws. This preservation is remarkable, and it has made the Arctic and subarctic a focus of intense archaeological interest. The things that come out of the permafrost when it thaws have rewritten what we know about human presence in the north. But permafrost also conceals things. The ground-penetrating radar surveys that have been conducted in permafrost regions over the past several decades have revealed that the frozen ground contains an enormous amount of information about what is inside it. The radar waves that penetrate the permafrost reflect back from structures within it, from layers of organic material, from buried water features, and from other things that do not have an obvious natural explanation. In the Mackenzie River Valley, which is one of the most geologically significant river systems in North America, ground-penetrating radar surveys, conducted in connection with pipeline route assessment, revealed a series of anomalies that were, in the polite language of the survey reports, flagged for further investigation. The further investigation was referenced in the subsequent survey documents as ongoing. In several cases, the further investigation was never reported publicly. One of these anomalies was located in a specific area of the Middle Mackenzie Valley, where the river, over many thousands of years, had deposited an enormous amount of sediment. The sediment layers in this area contain a record of everything that happened in the valley over a very long period. Geologists can read the layers like a book. identifying floods, droughts, changes in the river's course, and the presence of human activity through the materials embedded in each layer. What the ground-penetrating radar found in this location was a set of parallel linear features at a depth of approximately 4 to 7 meters below the current surface. The features were described in the survey report as extending for a distance of at least 40 meters, possibly longer, before passing beneath an area that the survey could not reach. They were oriented in a direction that was not consistent with natural river deposition. They were spaced at regular intervals. The spacing was what triggered the flagging. Regular spacing in geological features is not unheard of, but it is not common. And when it appears in a context where other natural explanations have been ruled out, it raises questions about origin. The survey report noted the features, noted their orientation and spacing, noted that they did not match any known natural feature type in the region, and recommended further investigation. The further investigation file is not public. The pipeline project moved forward. The route was adjusted in the relevant area, but not in a way that was explained in public documents as related to the survey anomaly. The adjustment was attributed to route optimization, and the ground-penetrating radar anomaly, and whatever is producing it at 4 to 7 meters below the surface of the Mackenzie Valley, is now permanently inaccessible beneath infrastructure that was built after the survey was conducted. When you start looking at what has been found in the permafrost regions of Canada and then moved into restricted archives, the picture that emerges is not a picture of random curiosity suppressed for bureaucratic reasons. It is a picture of something very specific being managed very carefully across a very long period. The management began before there was a formal mechanism for it. The Hudson's Bay Company, which controlled vast territories of what is now Canada for 2 centuries before Confederation, maintained its own records of what its people found in the interior. Those records are now in the archives of the Hudson's Bay Company, which are housed partly at Archives Manitoba and partly at other institutions. The records are voluminous, and most of them are mundane. Prices, inventories, correspondence about fur trade logistics. But within the records, if you read them systematically, there are references to things that the company's employees found and that the company's officers chose to handle in a particular way. The pattern of those references is consistent. A company employee traveling through a remote area encounters something unusual. The usual, in most cases, is a physical feature of the landscape that is clearly not natural, or a report from an indigenous guide about a specific location that the guide declines to approach, or an object that does not fit the expected material culture of any known group. The employee reports the find to his superior. The superior writes a letter to the company's headquarters in London, and then, in most cases, the trail goes quiet. The response from London, if there is a response, does not appear in the available records. The find is not mentioned again. In a handful of cases, the response from London is available. In those cases, the response is remarkable for what it does not say. It does not ask for more information. It does not direct the employee to conduct a further investigation. It does not express surprise or curiosity. It directs the employee to note the location carefully, to avoid the area if possible, and to refrain from discussing the matter with others at the post. The language is calm and administrative and absolutely definitive. Whatever the company knew about the interior of the continent, it knew enough to know that certain things were to be noted, located, and left alone. This pattern of noting, locating, and leaving alone is the original template for what would become the more formal processes of the Geological Survey of Canada and the various federal agencies that followed it. The informal understanding that certain things in the interior of this continent were better left undisturbed was established, in practical terms, 2 centuries before the formal mechanism for managing that understanding was put in place. The indigenous peoples of the territories where these finds were made had their own understanding of the same places, and their understanding was, in most cases, far older and far more detailed than anything the Hudson's Bay Company or the Geological Survey of Canada possessed. The Dene people, whose traditional territories cover enormous areas of what is now northern Alberta, the Northwest Territories, and parts of the Yukon, have oral traditions that describe the deep history of their relationship with the land in terms that include specific knowledge of places that are not to be approached. These places are described in the oral traditions not as dangerous in the sense of being physically hazardous, though some of them are, but as places that require a particular kind of attention and a particular kind of respect that most people, in the ordinary course of their lives, are not prepared to offer. The Dene word for these places does not translate cleanly into English. The closest approximation is something like places that are still doing what they were made to do. The implication is that these are places where something is ongoing, where a process or a presence that was established a very long time ago has not ended, and where ordinary human activity is not appropriate because the place is already occupied by something that was there first and has not finished whatever it came to do. This framing is very different from the framing that Western science uses for the same places. Western science, when it identifies an unusual feature of the landscape, tries to characterize and explain it. The Dene oral tradition, when it identifies the same kind of place, does not try to characterize or explain it. It notes that the place exists. It notes the appropriate behavior in relation to the place, and it passes that knowledge forward through the generations in a form that preserves the practical guidance without requiring an explanation of the underlying phenomenon. The practical guidance, in almost every case, is the same. Maintain a respectful distance, do not interfere, and do not take anything from the place or leave anything behind. These instructions have been followed by Dene communities for as long as the oral traditions record, which is a very long time. And in the cases where the instructions have been disregarded, either by members of the community who did not take the tradition seriously, or by outsiders who did not know the tradition existed, the outcomes that the oral traditions record are consistent enough to suggest that they reflect actual experience rather than abstract caution. The Geological Survey of Canada, to its credit, has in recent decades made significant efforts to incorporate Indigenous traditional knowledge into its survey work. There are now formal protocols for consulting with Indigenous communities before conducting surveys in traditional territories, and those protocols require that information shared by community members that be treated with respect and that the community have a say in how the resulting data is used. But the incorporation of Indigenous knowledge into the formal survey process has created a new version of the old problem. When an Indigenous community shares specific knowledge about a place that has particular significance, and that knowledge is then incorporated into a survey dataset, the question of how to handle the resulting information becomes complicated. The community may not want the specific location to be publicly documented. The Federal Crown has an obligation to consider whether the information affects existing rights, and the geologist, looking at the data, may be seeing a correlation between the place the community has flagged and an anomaly in the seismic or radar data that makes the situation even more complex. In at least a dozen documented cases in the last 30 years, the outcome of this kind of complexity has been the same as the outcome in the earlier, less consultative era. The specific information gets placed in a restricted file. The public survey report notes the area in general terms, and the detailed picture of what is actually there is maintained in a form that the public cannot easily access. There is a specific area in the Yukon where this pattern is particularly well documented, or as well documented as it can be, given that much of the relevant material is in restricted archives. The area in question is in the central Yukon, in a region where the terrain transitions from the lowland flats of the interior into the southern ranges of mountains that run north from British Columbia. The geology of this region is complex, with ancient rocks of the Shield interleaved with younger volcanic and sedimentary formations that record a complicated tectonic history. The whole region has been surveyed repeatedly for mineral resources, and the survey record is substantial. Within the survey record for this region, there is a consistent anomaly. The anomaly appears in aeromagnetic data, in seismic data, and in satellite radar data, and it appears in all of them in roughly the same location. A specific area of approximately 12 square kilometers shows, in each of these datasets, values that do not match the surrounding terrain and do not match any known geological feature type in the region. The aeromagnetic data shows a pattern of magnetic variation that is unlike the surrounding rock. The seismic data shows a zone where the velocity of seismic waves changes in a way that suggests the rock properties are different from what the surface geology would predict. The satellite radar data shows a subtle but consistent surface expression that is slightly different from the surrounding terrain, in a way that is consistent with a structural feature beneath the surface. Taken individually, each of these anomalies might be explained as a local geological quirk. Taken together, in the same location, they suggest something more coherent, a subsurface feature of substantial size and unusual character that has not been explained by any published geological interpretation. The anomaly has been noted in several survey reports. Each time it has been noted, the report has recommended further investigation, and each time, the further investigation has produced results that are not in the public version of the record. The most recent public document that touches on the anomaly is a GSC open file report from the 1990s that describes the aeromagnetic data for the region in question. The report notes the anomaly in a paragraph that is carefully worded. It describes the anomaly as consistent with a deeply buried intrusive body of unusual composition. It recommends geochemical sampling and follow-up seismic work. It does not mention the earlier investigations that had already been conducted, and it does not mention the satellite radar data, which by the time the report was written was available and had been applied to the region, that shows the surface expression of the feature. A researcher who noted this omission and asked the GSC about it received a response indicating that the satellite radar data for the region had been incorporated into a different dataset managed by a different federal agency, and that inquiries about that dataset should be directed to that agency. The other federal agency, when contacted, confirmed that it managed satellite radar data for various federal purposes and indicated that the specific dataset in question was restricted under a provision of the federal government's national security guidelines. The satellite radar data for a 12 square kilometer area of the central Yukon is restricted under national security guidelines. That sentence, which is a factual statement about the current status of a specific federal dataset, is worth sitting with for a moment. The national security of Canada, as it is ordinarily understood, does not obviously depend on information about what is 12 kilometers beneath the surface of a remote area of the Yukon. The Yukon does not contain major military installations that would make its deep geology a strategic secret. It does not contain nuclear facilities or other infrastructure whose security depends on geological secrecy. It is remote, thinly populated, and geologically important primarily for its mineral resources, which are matters of economic significance but not national security. And yet the satellite radar data for this specific area of the Yukon is restricted under national security guidelines, and the restriction has been maintained for several decades. The Yukon anomaly is not the only case of this kind. There are others, distributed across the country, where the intersection of anomalous geological data and restrictive federal handling produces the same pattern. Something was found, something was documented, and something about what was found led to the documentation being placed where the public cannot reach it. The geographic distribution of these cases is itself informative. They cluster in certain regions and they are absent from others, and the regions where they cluster tend to share certain characteristics. One of those characteristics is age. The regions where anomalous finds tend to be managed restrictively are, in many cases, regions underlain by the oldest rock on the continent. The ancient crystalline basement of the shield and its extensions into adjacent regions is where most of the cases cluster. The younger sedimentary rock that covers much of the western interior of Canada is not, in the available record, a source of the same kind of carefully managed anomalies. This is interesting because the oldest rock is, in geological terms, the least likely place to find large void spaces of natural origin. The processes that create natural caves in limestone, for instance, simply do not operate in granite and gneiss. If there are void spaces in the oldest rock of the Canadian Shield, they are either ancient relics of the early Earth's geological history that survived because of the shield's extraordinary stability, or they are not geological in origin at all. Both of these possibilities are remarkable. An ancient natural void space in billion-year-old rock would be a geological phenomenon of extraordinary significance, the kind of thing that would, under normal circumstances, be the subject of intense scientific interest and extensive publication. The fact that the void spaces that have been identified in the shield are not being extensively published suggests that the circumstances are not normal. The other possibility, that the void spaces are not geological in origin, raises a different set of questions. A void space in ancient rock that is not natural in origin is, by definition, constructed. And a constructed void space in rock that has been stable for 1 billion years raises the obvious question of what constructed it and when and why. The archaeological record of pre-contact North America has been, in recent decades, significantly revised. The picture of a continent sparsely populated by simple hunter-gatherers has been replaced, through a combination of new field research, new dating technology, and new attention to indigenous oral traditions, by a picture of a continent that was, in many periods and in many regions, much more densely populated and much more organizationally complex than anyone imagined 50 years ago. LiDAR surveys of the Amazon basin have revealed the outlines of a civilization of enormous scale. LiDAR surveys of parts of Southeast Asia have revealed similar complexity beneath forest canopy. In Canada, LiDAR surveys of the British Columbia interior have revealed evidence of pre-contact settlement patterns that are, in the words of the researchers who conducted the surveys, vastly more extensive than previously understood. The Old Copper Complex, which produced sophisticated copper artifacts in the Great Lakes region 8,000 years ago, demonstrates that pre-contact North Americans were capable of complex economic and organizational behavior long before anyone was willing to admit it. Against this backdrop, the possibility that pre-contact North Americans constructed features beneath the surface of the oldest rock on the continent is no longer as easy to dismiss as it might have seemed a generation ago. The question is not whether pre-contact peoples were capable of extraordinary things. The archaeological record, read honestly, makes clear that they were. The question is whether any of those extraordinary things extended into the deep ground of the Canadian Shield, and whether the people who have found evidence that they might have decided to manage that evidence in a particular way. The evidence that they have is circumstantial. It is a pattern of suppression, not a specific disclosed discovery. It is the accumulated weight of restricted files and national security classifications and access requests that came back with information withheld in full. It is the research notes of people who noticed the pattern and documented it in places that very few people read. It is the oral traditions of indigenous communities that have always known that certain places in the ground are not to be interfered with, traditions that align, with striking consistency, with the locations where the pattern of restriction is most pronounced. The alignment between indigenous traditional knowledge and the pattern of federal restriction is perhaps the most significant element of the whole picture, not because it proves that the traditional knowledge is describing the same thing that the geological data has found, though that may be the case, but because it demonstrates the depth of time involved. If indigenous communities have been maintaining specific knowledge about specific places in the ground for many generations, the places those communities are describing are not recent discoveries. They are ancient features of the landscape that have been there long enough for multiple generations of people to develop, transmit, and update the cultural practices surrounding them. The deep history of human presence in Canada is longer than most people realize. The conventional estimate for the first arrival of humans in North America has been pushed back repeatedly in recent decades as new sites are found and new dating methods applied. The site at Bluefish Caves in the Yukon contains evidence of human presence from approximately 24,000 years ago. Sites on the Pacific coast of British Columbia contain evidence of human occupation from 14,000 years ago. The peopling of the continent appears to have been earlier, more complex, and more extensive than the models of the 1960s and 70s allowed for. If humans have been in Canada for 24,000 years, and if they were capable, over that time, of developing the kind of sophisticated organizational and technological complexity that the archaeological record increasingly suggests, then the question of what they might have built and where they might have built it becomes genuinely open. 24,000 years is an enormous span of time. It encompasses multiple glacial cycles, multiple dramatic changes in the landscape, multiple periods during which the climate was radically different from what it is today. During the last glacial maximum, roughly 20,000 years ago, the Laurentide ice sheet covered most of Canada beneath kilometers of ice. Any feature of the landscape beneath that ice would have been crushed, ground down, or buried under glacial debris. But the ice did not cover everything equally. There were areas, particularly in the far north and in certain coastal regions, where ice was absent or much thinner, where the ground was accessible throughout the glacial period. These ice-free refugia are known to geological science and some of them are known to have been occupied by humans and other animals during the period of maximum glaciation. The Canadian Shield, paradoxically, is in some areas a place where geological stability through glaciation was possible, not at the surface, where the grinding action of glacial ice would have destroyed almost everything, but deep below the surface, where the rock was too hard and too ancient to be affected by the ice above. The ice did not reach into the deep rock. Whatever was deep in the rock before the ice arrived remained deep in the rock after the ice retreated. This geological fact is relevant to the question of what the people who have been surveying the Canadian Shield have found. If there are features in the deep rock that predate the last glaciation, those features are at least 20,000 years old. Features that are 20,000 years old in the Canadian Shield would be of extraordinary significance to the understanding of human prehistory on this continent. And the fact that such features, if they exist, have been documented and placed in restricted archives, rather than published and celebrated, tells you something about the decision that was made about how to handle them. The decision, as best as can be reconstructed from the available evidence, was made gradually, over a long period, by a succession of people in various institutions, who each dealt with a piece of the picture without necessarily seeing the whole thing. The geologist who noted the anomaly and submitted a report that was then classified did not necessarily know why the classification was applied. The archivist who maintained the restriction did not necessarily know what the restricted report contained. The federal official who applied the national security designation to the satellite radar data may not have had access to the decades of earlier restricted reports that covered the same ground. The management of this information has been, in other words, institutional rather than individual. No single person made a decision to keep the truth about what is beneath Canada from the public. Instead, a series of institutional processes, each operating according to its own logic and its own mandate, has produced a cumulative outcome that amounts to the same thing. Understanding this distinction matters because it changes the nature of the question. The question is not who decided to hide the secret. The question is what kind of secret is so persistent and so widely distributed that independent institutional processes, operating across different agencies and different time periods and different levels of government, keep arriving at the same decision to restrict the information that pertains to it. The answer to that question is, at this point, not publicly available. What is publicly available is the pattern of restriction, the geographic distribution of the restricted finds, the alignment between those finds, and the locations preserved in indigenous traditional knowledge, and the extraordinary geological age and stability of the rock in which the anomalies have been detected. These elements are consistent with several possible explanations. They are consistent with the presence of natural void spaces in ancient rock that have scientific significance for the understanding of Earth's early history. They are consistent with the presence of pre-contact human-made features of an age and character that would require significant revision of the standard account of human prehistory in North America. They are consistent with the presence of something that does not fit neatly into either of those categories, and that the people who found it have been treating with the same kind of careful, ongoing, institutional attention that the oral traditions of the people who have lived in this country for 20,000 years suggest it has always required. The Athabasca Basin in northern Saskatchewan is one of the most geologically surveyed areas in Canada. It is the site of some of the world's richest uranium deposits, and those deposits have attracted an enormous amount of exploration activity over the past century. The survey record for the Athabasca Basin is dense, detailed, and largely publicly available. Uranium exploration generates an enormous volume of geological data, and most of that data is eventually released to the public domain. Within that dense survey record, there is a specific area of the basin, in the eastern portion, where the ancient basement rock of the Shield comes close to the surface, where the exploration record shows a consistent gap. Not a gap in coverage, because the area has been surveyed multiple times using multiple methods. A gap in publication. The surveys were conducted, the data was collected, and then, in the case of this specific area, the detailed results of the surveys were not included in the public releases that covered the surrounding territory. The gap is not enormous. The area involved is perhaps a few dozen square kilometers, but it is consistent across multiple survey campaigns conducted by multiple companies over a period of roughly 30 years. Each campaign covered the region as a whole, released detailed results for the surrounding area, and produced publicly available documentation that referenced the covered area without providing the detailed results for the specific zone. A geologist working in the basin in the 1980s noticed this pattern and mentioned it to a colleague. The colleague's response was, according to the geologist's later account, that certain parts of the basin were subject to a different reporting protocol that had been in place for a long time, and that this was simply how things worked in that area. The geologist asked what the different protocol was. The colleague changed the subject. The geologist eventually left uranium exploration and moved into academic work. She wrote a paper, published in a minor journal, that described the gap in the Athabasca Basin publication record in general terms and noted that it was consistent with the kind of selective publication that could arise from either commercial secrecy or government intervention. The paper attracted almost no attention when it was published. It is still accessible through academic databases. The gap in the publication record that it describes is still there. The consistency of these patterns across different regions, different institutions, different time periods, and different industries is what makes the overall picture significant. This is not one instance of a government agency deciding to restrict a particular piece of information. It is a pattern that extends across the full history of geological and archaeological survey in Canada, from the Hudson's Bay Company's instructions to its employees about certain locations in the interior, through the National Museum's restricted archaeological reports of the mid-20th century, through the GSC's classified datasets of the 1970s and 80s, through the national security designations applied to satellite radar data in the 1990s and after. The pattern is consistent, and consistent patterns in the investigation of complex phenomena are significant. They do not prove a specific explanation. They point toward a class of explanations that is narrower than the full range of possibilities, and they invite the kind of sustained attention that might eventually narrow that class further. The people who have given this pattern that kind of sustained attention are, in most cases, not working within the institutions that generated the pattern. They are researchers working at the margins of academic disciplines, in fields that do not have strong institutional support for this kind of inquiry. They are journalists who have followed specific threads into archives and discovered, repeatedly, that the thread leads to a restricted file. They are Indigenous community members and knowledge keepers who have been carrying specific information about specific places for generations, and who watch, with something between patience and frustration, as the institutions that claim to be surveying those places announce, periodically, that they have found something interesting and then quietly transfer the finding to a place where it cannot be discussed. The knowledge keepers have something that the geological surveys do not have. They have continuity. The oral traditions that describe specific places in the ground of Canada have been maintained through every disruption that the last several centuries have brought. The residential school system, which attempted to sever the transmission of Indigenous knowledge from one generation to the next, the displacement of communities from traditional territories, the suppression of Indigenous languages in which the traditional knowledge was encoded, and the broader cultural pressure to abandon everything that did not fit within the framework of Western science and Western economic activity. The knowledge survived all of that, not intact, not everywhere, not without loss. But the core of it, the specific geographic knowledge of the places that require particular attention, survived in many communities because it was kept in the form of practical instruction rather than abstract belief. The instruction to maintain a respectful distance from a specific location does not require a philosophical framework for its preservation. It only requires that someone remember to pass it on, and that the person it is passed on to trust the person who passed it on enough to follow it. The survival of that knowledge, across the disruptions of the last several centuries, is itself a kind of evidence. Things that people have been instructed to remember and act upon for many generations are things that matter. The specific geographic precision of the traditional knowledge, the fact that it points to particular places rather than describing a general attitude toward the landscape, is consistent with knowledge that has a practical basis. Knowledge that was developed through experience of what happens at those specific places, and that was preserved because the experience was consistent enough to make the practical instruction reliable. The formal archaeological investigation of the places identified in Indigenous traditional knowledge has been, in the Canadian North, limited. This is partly because the terrain is difficult, partly because the resources for field investigation in remote areas are always constrained, and partly because the communities that hold the relevant knowledge are not always willing to share it with external investigators. The last of these is entirely understandable. The history of how Western institutions have handled knowledge shared by indigenous communities is not a history that inspires confidence. The default response of many communities to requests from government scientists or academic researchers for information about traditional knowledge is a form of careful assessment that takes time and requires the development relationships built on something more than professional interest. In some communities, that assessment process has resulted in decisions to share specific knowledge with specific researchers under specific conditions. The conditions typically involve guarantees about how the information will be used and who will have access to it. And in some cases, the conditions include requirements that certain specific locations, whatever geological or archaeological investigation is conducted at them, will remain off-limits to permanent physical documentation that could place the location in a public database. The interaction between these community conditions and the federal survey process has produced, in at least several documented cases, a situation where a survey team knows the location of something significant. The community has confirmed that the location is significant in the traditional knowledge. The survey data shows something anomalous at the location, and the full documentation of all of this is maintained in a restricted form that respects the community's conditions but also, conveniently for other institutional interests, keeps the information inaccessible to the general public. Whether this outcome is primarily a function of genuine respect for indigenous rights or primarily a function of institutional convenience is a question that cannot be answered from the outside. Probably it is both, in proportions that vary from case to case. What is certain is that the outcome, the restriction of specific information about specific places, is the same regardless of which motivation is primary in any given instance. The underground river systems of Canada add yet another dimension to this story. Canada contains, at the surface, an enormous proportion of the world's fresh water. The Great Lakes alone hold about a fifth of the world's surface fresh water. The river systems that drain the country into Hudson Bay, the Arctic Ocean, the Atlantic, and the Pacific are among the largest in the world. The country is, in every visible sense, a place defined by water, but the water that is visible at the surface is only part of the hydrological picture. Below the surface, in the fractured rock of the Canadian Shield, and in the sediments and porous rock that surround it, there are enormous quantities of water. Some of it is ancient, water that entered the ground tens of thousands of years ago when the climate and landscape were radically different from what they are today. Some of it moves, slowly, through connected systems of fractures and porous zones that form a kind of underground drainage network. And some of it, in specific areas of the country, is associated with features that have been documented and restricted in the same way that the other anomalies have been. The Cambrian aquifer system, which underlies parts of northern Ontario and Manitoba and extends into adjacent areas, is a major groundwater system that has been studied in connection with the potential disposal of nuclear waste. The geology of the Shield makes it, in theory, a candidate for the deep geological repository that Canada has been developing for used nuclear fuel. The study of the Shield, in connection with nuclear waste disposal, has produced an enormous amount of new data about the deep structure of the rock, data that is largely publicly available because the public interest in nuclear waste disposal is intense and the regulatory process requires transparency. Within that transparent dataset, there are specific areas where the transparency stops. Areas where the drill cores and seismic profiles that have been produced in connection with the nuclear waste study show features that the public summary documents describe in general terms without providing the specific data. The reason given, in public documents that address the question, is that the specific data is subject to ongoing assessment in connection with the site selection process, and will be released when the assessment is complete. The site selection process for Canada's deep geological repository has been ongoing for several decades. In that time, the specific data for certain areas of the Shield has remained in the ongoing assessment category, which means it has remained outside the public domain. The site selection process, like the geological survey process and the archaeological notification process, has proven to be an effective mechanism for keeping certain specific information in a state of perpetual pending review that functionally amounts to permanent restriction. The permafrost that covers so much of northern Canada is, as noted earlier, thawing. The thawing is accelerating, and as it thaws, it is revealing things that have been frozen and preserved for thousands of years. The rate of revelation is increasing, and the institutions that are responsible for documenting and managing what is revealed are increasingly aware that they are dealing with a volume of new information that is larger than anything they have managed before. Some of what is being revealed is unambiguously archaeological. Frozen plant material, frozen bone, frozen wood, frozen organic deposits that contain information about the ecosystems and peoples of the past. This material is being documented and studied and published with reasonable openness because it fits within the existing framework of what archaeological investigation in the North produces, and because the scale of it makes it impossible to manage restrictively. There is simply too much of it coming out of the ground in too many places for the old pattern of selective restriction to be effective. But within the material emerging from the thawing permafrost, there are specific instances that do not fit neatly within the existing framework. There are places where the permafrost, as it thaws, is revealing not frozen organic deposits, but the edges of structural features that are clearly not natural. These features are not emerging from the soft permafrost of lowland areas, where ice wedge polygons and thermokarst features are common. They are emerging from the margins of the shield, in areas where the permafrost is thinner and the underlying rock is close to the surface, and where the structure of the rock itself is being exposed in ways that reveal features that had been hidden beneath the frozen ground. The documentation of these features is ongoing. Some of it is in the public domain, some of it is not. The pattern of what is and is not in the public domain follows, with remarkable consistency, the same pattern that has characterized the management of anomalous geological and archaeological information in Canada for as long as records have been kept. The permafrost is revealing secrets. Whether those secrets will remain in restricted archives, or whether the pace of revelation is fast enough and widespread enough to finally break the pattern of selective management, is a question that only time will answer. There is one more element of this story that needs to be addressed, and it is perhaps the most difficult to handle with appropriate precision because it exists at the intersection of the documented pattern of restriction and the indigenous oral traditions that describe what is in the restricted places. The oral traditions of multiple indigenous nations in Canada describe, with varying degrees of specificity, the presence beneath the ground of something that is not geological and not archaeological in any ordinary sense. The traditions do not describe mines or ancient settlements or buried artifacts. They describe places where something is present that was present before the first humans arrived in the territory, that has been present continuously since then, and that has its own relationship with the land and its own requirements for how the land around it should be treated. The language used to describe these places in different traditions is different, because the traditions come from different cultural and linguistic backgrounds. But the functional content of the descriptions is consistent enough to suggest that they are describing the same category of phenomenon. The descriptions consistently involve a specific location, a specific depth or direction within the ground, a requirement that the place be approached only in specific ways and by specific people, and a sense that the place is not empty but occupied, not inert but active, not finished but ongoing. The geographic distribution of the places described in these traditions is not publicly documented in a comprehensive way. This is again largely because the communities that hold the knowledge have reasons not to place it in a public database. But the partial documentation that is available through the work of researchers who have worked in specific communities with specific permissions suggests that the places described in the traditions are not randomly distributed across the landscape. They cluster, and they cluster in ways that are consistent, in some cases, with the geographic distribution of the anomalies in the geological survey record. This consistency between two completely independent lines of evidence, one from Western geological science and one from indigenous oral tradition, is the most significant single element of the overall picture. Independent lines of evidence that converge on the same geographic locations are, in science, treated as meaningful. They do not prove a specific explanation, but they do narrow the range of plausible explanations, and they suggest that the phenomenon being pointed to by both lines of evidence is real. What that phenomenon is, precisely, is not known. It has been managed and restricted and maintained in a state of institutional opacity for long enough that the original documentation of what was found and when and by whom is itself deeply buried in restricted archives. The people who did the original work of documenting the anomalies may themselves not have known what they were documenting, because they were working in a tradition of scientific investigation that did not have a good framework for certain categories of observation. The framework that the indigenous oral traditions provide is different. It is not a scientific framework in the Western sense. It does not seek to characterize and explain. It seeks to describe the appropriate relationship between human activity and a phenomenon that is understood to be older and more persistent than human activity itself, and within that framework, the appropriate response to finding something beneath the ground that you do not fully understand is not to publish the data and open it to general inquiry. It is to maintain the respectful distance that the phenomenon requires, to document the location so it can be avoided and protected, and to pass that documentation forward in a form that will survive. The federal institutions of Canada have arrived, through a very different route and with very different motivations, at something functionally similar. They have found things. They have documented them. They have placed the documentation somewhere restricted, with reasons that are partly bureaucratic, partly political, partly economic, and partly something else that the available records do not explicitly state. And they have maintained the restriction across decades and institutional changes and shifts in government and policy with a consistency that suggests the motivation for maintaining it is something more than routine bureaucratic inertia. What is beneath Canada, in the specific places where the pattern of restriction is most pronounced, is not publicly known. But the fact that it is not publicly known, and the specific and consistent way in which it's not being known has been managed across a very long period of time, tells you something important about its nature. Things that are simply sensitive for ordinary reasons do not generate this kind of persistent, multi-institutional, cross-generational management. Things that are routinely inconvenient for bureaucratic or commercial reasons get restricted for a while and then released. The things that stay restricted across all the changes that a country goes through over more than a century are the things that the people who found them decided, at some level, that the world was not ready for. Whether the world is ready now, and whether the pattern of restriction that has characterized the management of this information will eventually give way to the kind of open investigation that the questions it raises deserve, is not something that can be predicted from the available evidence. What can be said is that the questions are real, the pattern of restriction is real, the indigenous oral traditions that point to the same places are real, and the geological anomalies that the survey data describes are real. The full picture of what they add up to is, for now, in a file that the public copy does not include. The Canadian North is a place where the scale of things defeats ordinary comprehension. The distances are incomprehensible to anyone who has not travelled them. The geological timescales involved are incomprehensible to anyone accustomed to thinking in human terms. The depth of indigenous knowledge about the landscape, accumulated across 20,000 years of continuous presence and attention, is incomprehensible to anyone accustomed to thinking of knowledge as something that lives in libraries and databases and published papers. All of that incomprehensibility is part of the story. The things beneath Canada are hard to understand, not only because the documentation of them has been managed and restricted. They are hard to understand because the frameworks we use for understanding, the frameworks of Western science and Western history and Western political governance, are not adequate to the scale and antiquity of what they are dealing with. The Canadian Shield is 4 billion years old. The human presence on the continent is at least 24,000 years old and probably older. The oral traditions that describe the places that the federal institutions have found and restricted are, in the most conservative estimate, many thousands of years old. And the things those traditions describe, the places that were present before the first human beings arrived and that have been present continuously since then, are older than all of that. Against that scale, the century and a half of formal geological survey, the decades of restricted archives, the succession of access to information requests that came back with information withheld in full, are very recent events. They are the beginning of an encounter between institutions designed for ordinary human purposes and something that has been underneath the ground of this continent for a very long time, doing whatever it has always done, waiting with what appears to be enormous patience for the question of how to handle it to be resolved. The question has not been resolved. The restricted files are still restricted. The pattern of silence that surrounds specific places in the Canadian Shield is still intact, maintained by the accumulated weight of institutional habit and the specific instructions of people in multiple agencies and multiple time periods who decided that the world was not yet ready for what those files contain. Maybe they were right. Maybe the scale of what is beneath Canada is in fact too large for the institutions of a country that has existed for a little over 150 years to handle in public. Maybe the Indigenous communities that have been carrying this knowledge for 20,000 years have been doing something important, not just for themselves, but for the rest of us, holding a responsibility that the formal institutions of the country are not yet prepared to share. Or maybe the time for that assessment has passed, and the accumulated evidence, the pattern of restriction, the geographical clustering of the anomalies, the alignment between the survey data and the oral traditions, the permafrost that is thawing and revealing more every season, has reached a point where the choice to keep it managed is no longer sustainable. The ground beneath Canada is very old, the secrets inside it are older, and the world, in the end, has a way of finding out what it was not supposed to know. Not because anyone decides to release it, but because the ground itself keeps moving, the permafrost keeps thawing, and the things that have been managed and restricted and maintained in institutional opacity for a very long time keep finding their way toward the surface. The survey teams will go out again next season. They will collect more data. Some of it will be published. Some of it will be placed in a restricted archive where a researcher, years from now, will try to access it through a formal request and receive a response, indicating that the information is withheld in full under a provision relating to ongoing federal interest in the subject matter. And the places themselves, the specific places in the ground of Canada that the oral traditions have described and the survey data has confirmed and the federal institutions have managed with such consistent care across such a long period of time, will continue doing what they have always done, whatever that is. If you want to keep exploring these stories with me, hit subscribe and drop a comment below telling me where in the world you are right now. And if you have your own piece of this puzzle, something you found in a document or a record or a family account that fits this pattern, I would genuinely like to hear it. These stories do not end when the video does. To understand how the pattern of what is not known about the Canadian subsurface has been shaped, you have to understand the institutional history of the people responsible for knowing about it. That history begins with the Geological Survey of Canada and extends outward over time to include a set of agencies and departments whose relationships to each other and to the information they collectively manage is not always visible from the outside. The Geological Survey of Canada was established in 1842. That is older than the country. It predates Confederation by 25 years. In those early decades, the survey's work was foundational in a very literal sense. It was producing the first systematic knowledge of what the country's territory was made of, and that knowledge was being used to determine what kind of country Canada would be. A country rich in mineral resources develops differently from a country that is not. The survey's findings shaped the economic and political character of Canada before the political character of Canada was fully determined. Logan understood this. He understood that the survey's work was not just scientific, but fundamentally political, that what the survey found would determine what claims the Crown could make, what resources could be developed, what territories were worth defending, and he operated accordingly, with a careful understanding of which findings should be emphasized and which should be noted quietly and set aside until the political context made them manageable. This political sensitivity is evident in the survey's records from the very beginning. Logan's correspondence includes letters to the Provincial Secretary of Canada that are notably careful in distinguishing between what the survey has found and what the survey is releasing publicly. The distinction was not always dramatic. Often, it reflected straightforward commercial sensitivity. A mineral deposit found during a publicly funded survey was technically a public resource, but the timing of its release could be managed to prevent premature speculation. This kind of management was accepted practice in the mid-19th century and is not particularly remarkable. What is remarkable is the category of find for which Logan's correspondence suggests a different kind of management. In at least 3 letters from the 1850s, Logan refers to features encountered during fieldwork in the shield in terms that distinguish them clearly from mineral or geological phenomena and that suggest a different kind of institutional attention. The letters are in the archive of the GSC at Library and Archives Canada in Ottawa. They are not restricted, but they have not been systematically analysed in the context of the larger pattern of restricted finds, because no one who has worked through the archive looking for this specific thread has had both the access to the geological survey data and the knowledge of the broader pattern needed to recognise what the letters are describing. One of the letters, written in the summer of 1857 to a senior official in the colonial administration, describes a feature encountered by a survey party in the country north of what is now Sudbury. The party was in the Shield, in terrain that was extremely difficult to traverse and that had not been visited by European survey teams before. The letter notes that the party encountered, on the third day of travel north of their base camp, a section of exposed rock face that showed, in Logan's words, features inconsistent with any natural process of formation. The letter does not elaborate on what those features were. It notes the position of the feature and states that the position has been recorded in the party's private field notes rather than the general survey record, and that it would be discussed in person rather than by correspondence when Logan next had the opportunity to meet with the official directly. The in-person meeting took place, presumably. The discussion that occurred in it is not recorded anywhere that is publicly available. The position noted in the private field notes, if those field notes survive, would be in a collection somewhere in the federal archives that has not been systematically cross-referenced with the geological survey record for that area. This is how the pattern begins, not with a decision to suppress, but with a decision to handle a particular finding differently from the routine findings of a geological survey, through a private channel rather than the public record, with a geographic position noted privately rather than officially. This decision, made in 1857 by a meticulous and careful scientist who clearly understood the significance of what he was doing, established a template that the institutions that followed the Geological Survey of Canada have, in their various ways, continued to follow ever since. The template is not complicated. It does not require coordination between agencies. It does not require a central authority that manages the suppression of information about what is beneath Canada. It requires only that the people who encounter specific kinds of findings in the Shield adopt the same basic attitude that Logan adopted, that these findings are real, that they are significant, that they require careful handling, and that the appropriate handling is private documentation and controlled disclosure rather than routine publication. An attitude that is shared, without explicit coordination, by the people who work in a specific field, in a specific region, over a long period of time, produces the kind of consistent pattern that is visible in the Geological Survey record of Canada. Not because anyone directed it, but because the people involved are responding, individually, to the same phenomenon in the same way. The phenomenon teaches them what the appropriate response is, and they teach each other, informally and without policy or procedure, in the way that professional communities always transmit knowledge about how to handle situations that the formal procedures do not adequately address. The Deep Earth Imaging Program, which the GSC launched in the 1980s to conduct comprehensive seismic imaging of the lower crust and upper mantle beneath Canada, produced more high-resolution data about the deep structure of the Shield than any previous research effort. The program used state-of-the-art seismic technology to image the crust to depths of several tens of kilometers, producing a picture of the deep structure of the Shield that was unprecedented in its resolution and coverage. Most of the data from the Deep Earth Imaging Program is publicly available. The GSC published it through its open file series, through peer-reviewed journal articles, and through presentations at international conferences. The program was, by scientific standards, remarkably transparent. In the full dataset, which can be accessed through the GSC's data archives, there are a small number of profiles that are different from the others. These profiles cover specific areas of the Shield where the seismic data shows anomalous features that are described in the technical documentation in terms that are precise and minimal. The features are noted, their positions are given, and the documentation notes, without elaboration, that the features are subject to ongoing assessment by the relevant agency. The relevant agency is not named in the documentation. The ongoing assessment is not described, and the specific locations of the features within the Shield are given in coordinates that correspond to areas where, in each case, there is an existing pattern of unusual findings in the geological and archaeological record. The deep Earth imaging data was reviewed, at some point during or after its collection, by someone who identified the anomalous profiles and determined that they required a different handling than the routine profiles. That person, or those people, made a decision that is not documented publicly, but whose effects are visible in the data. And the decision they made followed the same template that Logan established in 1857. Note the position, handle the finding privately, and leave the public record with a reference to ongoing assessment that provides no detail. There is a specific quality to the anomalous features in the seismic data that distinguishes them from the routine geological anomalies in the same dataset. Routine geological anomalies are heterogeneous. They reflect the complex and chaotic history of rock formation in the shield, the ancient collisions of crustal plates, the intrusions of younger rock into older, the deformation of formations over billions of years. They look like what they are, the signature of a very old and very complex geological history, full of irregularity and variation. The anomalous features in the restricted profiles are not heterogeneous. They show a degree of internal regularity that is not consistent with natural geological processes. The regularity is not architectural in an obvious visual sense. It is expressed in the seismic data as a pattern of velocity contrasts and reflection amplitudes that has a quality of organization that the surrounding rock does not have. Whether this organization reflects a natural feature that has not yet been adequately explained by geological science, or whether it reflects something that geological science does not have a framework for, is precisely the kind of question that the ongoing assessment is, presumably, intended to answer. The ongoing assessment has been ongoing for a very long time, without producing any public results. The history of human habitation in the territories now comprising Canada extends much further back than the standard historical narrative acknowledges. This is not a controversial statement within academic archaeology. The evidence for early and extensive pre-contact habitation has been accumulating for decades, and the picture that emerges from the current state of the field is of a continent that was, at various times and in various regions, far more densely populated and organizationally complex than the standard narrative allows for. The sites that have driven this revision are primarily surface sites or near-surface sites, camps, villages, mound complexes, shell middens, pictograph sites, and other features left by people who were living on the surface of the land. The evidence from these sites is, in the aggregate, compelling. It tells a story of long and continuous human presence in Canada, of sophisticated ecological management, of extensive trade networks, and of organizational forms that required levels of cooperation and planning that the standard narrative attributed only to post-contact European settlement. What the surface site evidence does not tell you is what was happening below the surface. Archaeological investigation of below-surface features in Canada has been limited, partly by the difficulty of the terrain, partly by resource constraints, and partly by the same pattern of institutional management that has characterized the handling of geological anomalies. In the cases where below-surface investigation has been conducted at sites of pre-contact habitation, the results have sometimes been remarkable. At a site in northern Ontario, investigated in the 1970s under the auspices of a joint provincial and federal program, excavation of what appeared to be a surface habitation site revealed, at a depth of roughly 3 meters, a continuation of the habitation record into a geological formation that the surface investigation had not suggested was present. The formation, which consisted of a series of layered deposits containing cultural material, extended further downward than the excavation was able to follow. The excavation reached a depth of approximately 5 meters before encountering a layer of compacted material that resisted further investigation with the equipment available. The site report for the 1970s investigation notes the subsurface deposits and the depth of the deepest cultural material reached. It recommends further investigation. The further investigation was conducted in the 1980s, with equipment capable of reaching greater depths. The report from that investigation is not publicly available. The public summary notes that the investigation was conducted and that the results were forwarded to the relevant federal authorities. The relevant federal authorities did not publish the results. The site is still registered in the Provincial Archaeological Site Database. Its registered description is the description from the 1970s surface investigation. The results of the 1980s subsurface investigation do not appear in the database. They are, presumably, in a restricted federal file somewhere. The depth of the subsurface deposits at the Northern Ontario site, and the fact that they were still containing cultural material at 5 meters below the surface, is interesting in light of the geological history of the region. The deposits that accumulate at the surface in this part of the shield are not thick. The shield is old, stable rock, and the accumulation of surface material on top of it has been relatively slow. A deposit of cultural material at 5 meters depth is, in this geological context, very old, potentially much older than that. Old enough that its age, if it were published, would substantially revise the existing understanding of when people were living in this particular part of Canada. There is a reason why questions about the age of the earliest human habitation in Canada are significant beyond purely academic interest. The question of when people arrived in a particular territory is not only a scientific question, it is also a legal and political question. The legal framework governing Indigenous rights in Canada is built, in part, on the principle that Indigenous peoples were the first occupants of the land. The earlier that first occupation can be demonstrated, the stronger the legal case for the associated rights. And the more complex and sophisticated that early occupation can be shown to have been, the harder it is to maintain the historical narrative that has been used to justify various aspects of the colonial relationship between the Canadian state and Indigenous peoples. This is not the only reason why the institutional management of information about early habitation is politically sensitive, but it is one of them. An archaeological record that demonstrates continuous and sophisticated habitation in a territory from 20,000 years ago to the present is a very different legal and political context from an archaeological record that begins with a few scattered camps from 4,000 years ago. The people who manage the institutional processes of archaeological survey and reporting are not always thinking in these terms, but the political context in which they operate is shaped by these considerations. The intersection of geological anomaly, archaeological evidence, and political sensitivity is exactly where the pattern of restriction is most consistent and most durable. The places where all three elements are present together are the places where the full picture of what is beneath Canada is most thoroughly managed. There is a geological formation in the western part of the shield, in a region that straddles the border between Saskatchewan and Manitoba, that illustrates this intersection with particular clarity. The formation is a zone of ancient metamorphic rock that contains, within it, a set of fractures that form a connected system of cavities and passages at a depth of roughly 200 to 300 meters. The existence of this system was established through seismic survey work conducted in connection with mineral exploration in the 1970s. The system is large. The connected extent of the cavities, as estimated from the seismic data, is several kilometers in its longest dimension. The cavities themselves are not enormous individually, but their connected character makes the system as a whole a significant feature. What makes the system particularly interesting is not its size, but its location within the fracture pattern of the rock. The fractures that form the system are not randomly distributed. They have a preferred orientation that is consistent with a structural feature in the rock that was formed during the earliest period of the shield's history. The feature runs for hundreds of kilometers across the region, and it appears, in the seismic data, to connect the fracture system in the Saskatchewan-Manitoba border region to other anomalies further north and east in the shield. The full extent of this connected structure has never been published. The seismic data that establishes the connection is in the mineral exploration records of the companies that conducted the surveys, and those records, while technically subject to public release after a certain period, are in practice difficult to access and have not been systematically analysed in the way that would reveal the full picture. A geologist who worked in the region in the 1980s described, in a conversation with a colleague who later documented it, a set of findings from the seismic surveys that went significantly beyond what was included in the public documentation. The colleague documented the conversation in a research notebook that was eventually donated to a university archive. The notebook is accessible, in theory, to researchers. The specific entry describing the conversation has not, as far as is known, been published or referenced in any academic work. The geologist described the connected fracture system as extending from the known anomaly in the Saskatchewan-Manitoba border region northward into a part of the Shield where the survey coverage was less dense. In the areas of sparse coverage, the available data suggested that the connected system continued, but the specific character of what it connected to in the north was, in the geologist's account, something that the survey team had decided should not go into the public documentation of the surveys. The geologist said this with the matter-of-fact tone that the colleague noted as characteristic of someone describing an institutional practice that was so well established that it required no explanation. The practice did not require explanation because everyone in the relevant professional community understood it. When certain kinds of things are found in certain kinds of places in the Canadian Shield, they get handled a certain way. This is not a conspiracy, it is a professional norm. And professional norms, once established, are maintained by the same mechanism that maintains all professional norms. The accumulated weight of precedent, the informal transmission of how things are done, and the social pressure on individual practitioners not to be the person who breaks with established practice in ways that create problems for the people around them. Breaking with established practice, in the specific case of the pattern of restricted findings from the Canadian Shield, would mean publishing data that the institutional norm says should not be published. It would mean going on the record with findings that other people in the field have, for as long as anyone currently working can remember, handled through private channels and restricted archives. It would mean being the person who, by publishing, forces the question of what all of this restricted material actually contains and what it means. No one has done this, as far as is known. The professional norm has held for as long as the relevant professional community has existed, and in a community that is small, specialized, and dependent on institutional relationships for its access to the field sites and the equipment and the funding that make the work possible, the incentives for maintaining the norm are strong, and the incentives for breaking it are weak. The researchers who have gotten closest to breaking the norm are the ones who work outside the community. The archivists and records researchers who have identified the pattern of restriction through systematic work in public archives, the journalists who have followed specific threads through access to information requests, the Indigenous knowledge keepers, and the researchers who work with them, who have a different kind of access to the relevant information and a different relationship to the institutional norms that govern its management. These outsiders have been able to describe the shape of the pattern, but not the content of the restricted files. They can tell you that the files exist, where they are likely to be located, and what the access requests revealed about the reasons for restriction. They cannot tell you what is in the files, because they have not been allowed to read them. The picture that emerges from the outside is therefore necessarily incomplete. It is a picture of a shape, not a picture of what fills the shape. The shape is clear, a pattern of specific geographic locations in the Canadian Shield and adjacent regions where geological survey data shows anomalies, where Indigenous traditional knowledge describes significant features, where the intersection of these two lines of evidence has been consistently handled through restriction rather than publication, and where the restriction has been maintained across institutional changes and policy shifts and changes of government for longer than most people working in the relevant fields have been alive. The shape of the pattern is enough to tell you that something significant is being managed. It is not enough to tell you what that something is. To get closer to an answer, you have to look at the few cases where the management process has partially broken down, where information has emerged from restricted channels through accident or oversight, or the decisions of specific individuals who concluded that the management had gone on long enough. One such case involves a researcher who worked for the federal government in a capacity that gave him access to restricted geological survey data in the 1990s. The researcher, whose name is not used here because he is still living and has not consented to being publicly identified in connection with this story, was working on a project that required him to review a collection of archived survey files that included both public and restricted material. The collection had been assembled from multiple sources, and in the process of assembly, a number of restricted documents had been filed alongside public documents without the standard restricted labeling that would have directed him to handle them differently. The researcher read the documents before he realized they were restricted. When he realized what he had read, he reported the situation to his supervisor, who instructed him to return the documents to a restricted file and to treat everything he had read as subject to his existing confidentiality obligations. The researcher did this. He did not publish what he had read, but he did, in the years after he left federal employment, discuss what he had read in general terms with people he trusted, including a journalist who was working on a story about federal information management. The journalist's story was never published, because the journalist's editor concluded that the general terms in which the researcher was willing to speak did not provide enough specific information to support publication. The journalist documented the conversation in notes that remain in her personal files. She has spoken about the conversation in general terms to other people in her professional network, and the content of what she said has been described at several removes in accounts that are accessible if you know where to look. What the researcher read in the documents he was not supposed to have seen was a series of assessment reports describing features found at specific locations in the Canadian Shield in the mid-20th century. The features were described in the assessment reports in terms that the researcher found, in his words, very difficult to categorize within the framework of geological science. The reports were written by scientists, using scientific language, but the phenomena they were describing did not fit within the categories of geological phenomena that the researcher was familiar with. The reports described structures. The structures were at specific depths in specific rock formations. The structures were not natural. The reports described the structures in terms of their dimensions, their orientation, their physical character, and their relationship to the surrounding rock. The dimensions were, in some cases, very large. The orientation was, in several cases, apparently systematic in ways that suggested planning rather than accident. The physical character was, in the descriptions, unlike any known natural geological feature. The reports also described the history of the features, when they were first found, by which survey team, using what methods, and what the subsequent assessments had determined about their character and extent. In several cases, the history went back to surveys conducted in the 1940s and 50s. In one case, the history referenced observations made by a geological survey party in the late 19th century, with a note that the location had been documented privately at the time, and that the subsequent formal survey had confirmed the private documentation. This last detail, the note about documentation that went back to the late 19th century and had been confirmed in the formal survey record, is consistent with the pattern established by Logan's management of unusual findings in the 1850s. It suggests that the restricted files maintain a continuous record that goes back to the beginning of systematic geological survey in Canada, and that the specific locations in the Shield that have been managed restrictively have been managed in that way since they were first encountered. The researcher described the feeling of reading those documents as deeply disorienting, not because the documents were sensational, he was careful to say. They were not sensational. They were written in the flat, technical language of official scientific reports. But the content of what they described, set against his professional knowledge of what the Canadian Shield was supposed to contain, was something he found very hard to hold in his mind in a normal way. This disorientation is, in its own way, informative. A scientist with deep knowledge of the Canadian Shield, reading official scientific reports about the Shield, describing the experience as disorienting because the content does not fit within his professional framework, is telling you something important about the nature of what those reports contain. It is telling you that what was found is not explicable within the existing framework of Canadian geology, and a finding that is not explicable within the existing framework of a well-developed scientific field is, by definition, significant. The significance is compounded by the institutional response to the finding. A finding that is not explicable within the existing framework of geological science, if it were handled in the normal way, would be the subject of intense scientific interest and extensive publication. The inability of the existing framework to explain a finding is not a reason to restrict the finding. It is an invitation to develop a new framework, which is how science progresses. The fact that the institutional response to these specific, unexplained findings has been restriction rather than publication tells you that the restriction is motivated by something other than scientific caution about prematurely publishing unexplained results. The motivation is harder to name. It is not commercial sensitivity in an obvious sense, because these are not mineral deposits whose commercial value would be affected by publication. It is not operational security in an obvious military sense. For the same reason as before, the Shield is not a militarily sensitive area. It is not indigenous rights protection in any current formal sense, because the restriction predates the legal framework that governs indigenous rights consultation. What it is, as best as can be reconstructed from the available evidence, is a form of institutional caution about the consequences of public knowledge of something that the institutions have determined the public cannot be given an adequate framework for. This is paternalistic, certainly. It is also, in a particular way, consistent with the attitude of the indigenous oral traditions that have been describing the same places for thousands of years. Those traditions do not describe the places in terms that are available to outsiders. They describe the appropriate relationship with the places, the appropriate behavior in relation to them, without providing an explanation of what the places are. The institutional pattern of restriction accomplishes something similar. It notes the locations, manages the relationship with them, and withholds the explanation. The explanation, if there is a single coherent one, would require a framework that does not yet exist in any publicly accessible form. It would require a framework that can account for features in billion-year-old rock that are not natural, that are of extraordinary scale, that have been present and apparently unchanged for long enough that they were already old when the first human beings arrived on the continent, and that are described by the oral traditions of those human beings in terms that suggest an active, ongoing presence rather than an inert relic of the past. Building that framework would be the work of a generation of researchers with access to the restricted files, the indigenous traditional knowledge, and the full dataset of geological survey findings that has been accumulated over the past century and a half. That work has not been done because the restricted files have not been accessible, and because the interdisciplinary collaboration required would demand a level of openness between geological science, archaeology, indigenous studies, and the federal institutions that manage the relevant archives that has not yet been achieved. The permafrost is thawing faster than any model predicted. The rate of change in the Canadian North is approximately 4 times the global average for surface warming. This means that the permafrost regions, which have been locked against thorough investigation for as long as the frozen ground has been frozen, are opening up at a pace that the institutional apparatus for managing what is found in them was not designed to handle. The institutional apparatus was designed for a rate of discovery that was slow enough to manage. A survey team finds something unusual in a specific area, files a report, the report gets reviewed, the restricted portions get placed in a restricted archive, and the pace of subsequent discovery in that area is slow enough that the management stays ahead of the findings. This is the model that has operated for over a century, and, for most of that time, it has worked. The thawing permafrost is changing the rate of discovery. Features that were locked beneath frozen ground are emerging, sometimes rapidly, as the permafrost collapses. The institutions responsible for managing what is found are, increasingly, in the position of trying to manage a volume of new findings that exceeds their capacity to handle each finding individually in the usual way. The result is a kind of managed overwhelm. The institutions are doing their best to apply the established protocols to the most significant findings, while a larger volume of less significant findings is handled with less individual attention. The gradient between what gets careful restricted management and what gets routine public documentation is shifting. Some things that would previously have been managed carefully are now being handled routinely, simply because there are too many of them to manage individually. This shift is visible, if you look carefully, in the recent public documentation of archaeological finds emerging from the permafrost in northern Canada. The documentation is more detailed and more candid than it was in previous decades. The reasons for the increased candor are complex. Part of it is the shift in the legal and political framework governing Indigenous rights, which has made it harder to simply restrict information that has implications for those rights. Part of it is the increased involvement of Indigenous communities in the documentation process itself, which brings in a perspective that is less amenable to institutional restriction, and part of it is simple volume. There is too much coming out of the thawing permafrost for the old management model to keep up with all of it. What is emerging from the permafrost includes, in a number of documented cases, organic material from periods that push the established timeline of human presence, in specific areas back significantly. Frozen wood from structures that predate the conventional date of first occupation in those areas. Frozen artifacts of a type that is not associated with any known cultural tradition from the region. Frozen deposits that contain a stratigraphic record of continuous human activity over spans of time that, if confirmed, would require substantial revision of the standard account. These finds are being documented with more openness than would have been the case 2 or 3 decades ago. They are generating peer-reviewed publications and public discussion. The increased openness is a positive development, but it is occurring at the surface level of the permafrost with the features that are accessible without deep investigation. The features that are deeper, that require active subsurface investigation rather than the passive documentation of what the thawing brings to the surface, are still subject to the same institutional management that has always governed such findings. The deep features have not changed because the permafrost above them is thawing. They are in the rock, not in the ice. The rock is not thawing. What is thawing is the layer of frozen ground that was, in a sense, an additional cover above the rock, an extra layer of inaccessibility that the institutional management of the restricted findings could rely on. As that layer disappears, the physical accessibility of the deep features increases. But the institutional management of the information about those features has not changed at the same rate. This creates a widening gap between what is accessible in principle and what is accessible in practice. The features are there. The survey data that describes them is in restricted archives. The rock that contains them is, in some areas, increasingly accessible to physical investigation. And the institutions that are responsible for deciding whether that physical investigation should be conducted and how its results should be handled are operating with the same protocols that were established when the features were both physically inaccessible and institutionally restricted. The gap between physical and institutional accessibility is where the next phase of this story will be written. Whether that phase will be written in the open, with full publication of the restricted findings and full collaboration between geological science, archaeology, and indigenous knowledge systems, or whether it will be written in the same restricted channels that have characterized the management of this information for 150 years, is the question that the next generation of researchers and knowledge keepers and federal officials will have to answer. The answer they give will depend, in part, on whether the institutions that have managed this information develop the capacity for a different relationship with it. Institutions change slowly. Their norms are durable. The professional culture that has maintained the pattern of restriction for so long is not going to transform overnight in response to changing physical conditions or changing political contexts. But it is also not going to be able to maintain the pattern intact indefinitely against the pressure of a changing landscape and a changing legal and political environment. The places in the shield are old. What they contain is older. The management of the information about them is, by comparison, very recent and very provisional. A century and a half against 4 billion years is not a long time. The institutions of Canada have had their hands on this information for a very short period of time relative to the age of what they are managing. And the oral traditions of the people who have been in this territory for 20,000 years are a reminder of how much longer the relevant timescale is than the institutional history of Canada. The Cree communities of northern Quebec and the adjacent territories have, within their oral traditions, a very specific account of the relationship between human beings and the deep ground of the shield. The account is not, in its traditional form, a story in the narrative sense that Western audiences tend to expect. It is more like a description of conditions. The conditions that existed before human beings arrived in the territory, the conditions that exist now, and the relationship between the two that has been maintained across the span of time that includes both. The description of pre-human conditions includes, in most accounts, references to the deep ground as already organized. Not organized by geological processes, which would be described differently, but organized in the way that something is organized when it has been intentionally arranged. The deep ground, in the traditional accounts, was already doing something when the people arrived. What it was doing was not fully explained to the people. What they were told was how to live alongside it without interfering. The instruction to live alongside without interfering is not passive. It requires active attention. It requires knowing which places are which, knowing what behaviors are appropriate at each place, and maintaining those behaviors across generations regardless of what other changes occur in the surrounding world. The Cree communities that have maintained this instruction have maintained it through every disruption of the past several centuries. They have maintained it through the arrival of the Hudson's Bay Company and the introduction of the fur trade, through the construction of railways and roads and pipelines and hydroelectric dams across their traditional territories, through the residential school system and the systematic assault on the transmission of their knowledge to the next generation. The instruction survived because it was carried by specific people who understood its practical importance, not as abstract cultural heritage, but as practical knowledge about the relationship between the people and the specific places in the ground of their territory. The people who carry this knowledge are not mystical figures. They are community members with a specific body of practical knowledge that has been transmitted to them carefully and that they carry with a combination of gravity and matter-of-factness that is characteristic of people who know something important and know it well. When these knowledge keepers talk about the places in the deep ground, they talk about them in terms that are very specific and very consistent. Specific locations, specific behavioral requirements, specific consequences of those requirements being violated, and a specific understanding of the ongoing character of what is in those locations. The ongoing character is what distinguishes the places in the deep ground from other significant features of the landscape. Other significant places, sacred sites, ceremonial locations, places of historical importance, are significant for things that happen there or for what they contain. The places in the deep ground are significant for what they are doing, and what they are doing is described as continuous, not past, not occasional, but ongoing. This is an unusual category for Western science to work with. Western science is comfortable with things that happened, things that contain, and things that are stable. It is less comfortable with things that are described as ongoing, in ways that do not have a clear physical mechanism. The places in the deep ground, as the Cree knowledge keepers describe them, are ongoing in ways that the Geological Survey data documents but does not explain, and that the institutional management of the relevant data has treated as too complex to be made available to general public discussion. The Ojibwe communities of northern Ontario have a related but distinct tradition describing their understanding of specific features in the shield. The Ojibwe account is more focused on the role of the deep ground in maintaining the conditions that make surface life possible. The deep ground is described as doing work, the same kind of work it has always done, and the surface, including the people and other living things that exist on the surface, is understood as dependent on that work continuing. The dependency is not framed as vulnerability, it is framed as relationship. The surface and the deep ground are in a relationship that requires mutual respect and appropriate behavior from the side of the surface, because the deep ground does not need the surface in the same way that the surface needs the deep ground. The asymmetry of this relationship is understood clearly in the tradition. The deep ground was there first and will be there last. The surface, including all the things and people on it, is a temporary feature of a much longer story. This framing, if taken seriously as a description of something real rather than dismissed as metaphor or folklore, suggests a very different relationship between the features in the deep ground and the surface world than Western science has been accustomed to considering. Western geology treats the deep ground as inert, ancient, chemically interesting, economically significant in certain places, but fundamentally passive in relation to the surface. The geological processes that operate in the deep crust are slow, impersonal, and indifferent to the surface world in any meaningful sense. The Ojibwe tradition describes the deep ground as anything but passive. It describes it as engaged in ongoing work that the surface depends on. What that work is, and how it relates to the features in the deep ground that the Geological Survey has documented and then managed restrictively, is precisely the kind of question that the intersection of Western science and Indigenous traditional knowledge could, in principle, begin to address if both sides of the intersection were working from a fully available shared dataset. That intersection has not yet produced that kind of collaborative investigation, partly because the relevant dataset is not fully available, partly because the institutional cultures of Western science and Indigenous knowledge systems have different norms and different timelines, and partly because the specific information held in Indigenous communities about the places in the deep ground is not always available for external sharing. The communities have reasons for their own forms of restriction that are distinct from the federal institutional reasons, and those reasons are legitimate and must be respected. But the fact that both sides of the intersection, the Federal Geological Survey apparatus and the indigenous oral traditions of the same territory, have independently arrived at a policy of careful management and restricted disclosure for the same places in the same ground, is telling. Two independent sources of knowledge about the same phenomenon, using completely different frameworks and completely different methods, reaching the same conclusion about how to manage the information, is not a coincidence. It is evidence that the phenomenon being managed has characteristics that make this kind of careful management appropriate regardless of the framework being used to understand it. What those characteristics are, and whether the word appropriate is the right word for a management approach that has, in the case of the federal institutional apparatus, involved the application of national security classifications to satellite radar data covering remote areas of the Yukon, is a question that this account cannot fully answer. What it can say is that the characteristics are real, that the management is real, and that the pattern of the management, consistent across time and across independent institutional frameworks, points towards something in the deep ground of Canada that is unlike anything in the standard picture of what a geological survey is expected to find. The summer field season in northern Canada is short. The window between the thaw that makes the terrain accessible and the freeze that closes it again is measured in weeks, not months, in many parts of the Shield. This brevity has shaped the pace of geological and archaeological investigation from the beginning. Survey teams have always operated under time pressure, and that time pressure has been one of the factors that contributed to the pattern of noting finds, recording positions, and moving on, rather than conducting the sustained in-place investigation that would be required to fully characterize an unusual finding. But the brevity of the field season is not the primary reason that the pattern of careful, private management of unusual findings has persisted. The primary reason is that the people who have found these things have made a consistent judgment across many instances and many time periods that the full public disclosure of what they found would produce consequences they were not prepared to manage. This judgment has been made, in various instances, by field scientists, by institutional officials, by company geologists, and by indigenous knowledge keepers, and they have made it from very different positions and with very different frameworks for understanding what they found. The fact that this judgment has been made consistently across all these different positions and frameworks is the clearest signal available that the thing being found is genuinely exceptional. People who work in a field where unusual findings are routine, where the daily work involves discovering things that were not previously known, do not develop a pattern of careful, private management in response to ordinary, unusual findings. They develop that pattern only in response to findings that, for whatever reason, they have concluded are too significant, too strange, or too difficult to handle through normal channels. The Canadian Shield is 4 billion years old. The features within it that have been found, documented, and restricted are, by the evidence of the geological context in which they appear, very old. How old is not publicly known, because the dating work that would answer that question is part of the restricted investigation that has not been published. Whether they are geological features of extraordinary age and character, or constructed features of extraordinary age and character, or something that does not fit neatly into either of those categories, is the question that the restricted files presumably address. What is known from the available public record is that the people who have reviewed the restricted files have found them worth keeping restricted, and that judgment, maintained across the full span of time since the Geological Survey of Canada first began systematically mapping the Shield, is perhaps the most significant single piece of evidence about the nature of what is beneath Canada that the public record contains. The world did not find out about the full extent of the ancient Cahokia complex in Illinois until LiDAR surveys made the full structure visible. The world did not find out about the full scale of pre-Columbian civilization in the Amazon until LiDAR surveys revealed the extent of earthworks beneath the forest canopy. The world did not know about the drowned archaeological sites on the coast of British Columbia until underwater survey technology made them accessible. In each of these cases, the technology arrived, the survey was conducted, and the picture changed. The technology to fully investigate what is beneath the Canadian Shield is becoming available. Ground-penetrating radar has improved dramatically. Deep seismic imaging has improved. Satellite-based sensors have become more capable. The data generated by all of these technologies is increasingly sophisticated, and the analytical tools for extracting information from the data are increasingly powerful. As these tools improve, the gap between what can be found and what has been allowed to be found is likely to narrow. Not because the institutional management of the information will necessarily become more open, but because the technology will eventually make some of the restricted information redundant. Findings that were managed restrictively because they were the only evidence of a particular phenomenon will eventually be confirmed by independent investigation that cannot be managed in the same way. When that happens, and the timescale on which it happens, is a matter of how quickly the technology develops and how quickly researchers with the relevant questions get access to it. The picture of what is beneath Canada will change. The restricted files will still be restricted, but the phenomenon that the files describe will be visible through other means, confirmed by independent lines of evidence, and no longer dependent on the restricted files for its documentation. At that point, the question of what to do about the restricted files will become unavoidable. The information in them will either confirm and enrich the picture produced by independent investigation, in which case their release will add detail to a picture that is already broadly known, or they will contain something that is not captured by the independent investigation, something that the institutional management has protected from even the most sophisticated modern remote sensing. If the latter is the case, then the restricted files still contain something that the world does not know, something that the people who have had access to the files have decided, for over a century and in some cases much longer, that the world is not ready to know, something that the indigenous oral traditions have been describing, in their own terms, for 20,000 years, in a language that tells you how to live alongside it, without telling you what it is. What it is, in the end, is the question that the available evidence cannot fully answer. But the available evidence is enough to tell you that it is there, that it has been found, that it has been managed, and that the management has been consistent enough, and durable enough, and geographically specific enough to be something other than routine bureaucratic caution about the publication of preliminary findings. It is enough to tell you that beneath Canada, in the ancient rock of the Shield, and in the frozen ground of the north, and in the deep sediments of the river valleys, and in the places that the oral traditions have been describing for longer than recorded history, there is something that the people in charge of knowing about it have decided you do not need to know. Not in the conspiratorial way, in the very plain, very bureaucratic, very well-documented way where a report gets filed, a government office reviews it, and the thing that was found gets a classification that means the full picture is somewhere you are not allowed to look. And the ground, which was doing what it was doing before any of this began, goes on doing it, patient and old, and not particularly concerned with the question of when the rest of you will find out. The Churchill River system in northern Manitoba is one of the most extensively studied river systems in Canada, studied primarily because it was fundamentally altered by hydroelectric development in the 1960s and 70s. The alteration was dramatic. The system was partially diverted, its flow redistributed, its lake levels changed, and its ecology transformed. The communities that depended on the river were displaced. The fish that had sustained those communities for generations were affected in ways that are still being assessed. But the study of the Churchill system produced, as a byproduct of the enormous engineering assessment that preceded the hydroelectric development, a detailed subsurface picture of the geology of the region that the system drains. The boreholes sunk for geotechnical assessment, the seismic surveys conducted for engineering purposes, the geological mapping done to understand the foundation conditions for the proposed infrastructure. All of this generated a comprehensive dataset about what is under the Churchill watershed. Within that dataset, in the boreholes sunk at specific locations in the central part of the watershed, the geotechnical record shows a set of anomalies at depth that were documented in the engineering assessment and then referred, in the manner that has become familiar in this account, to a separate assessment process that did not produce public results. The boreholes that show the anomalies were sunk in areas where the bedrock of the shield comes closest to the surface. At two specific locations, the borehole records show, at depths of roughly 120 to 150 meters, a change in the physical character of the rock that the engineering assessment describes as a sharp contact with an unusual formation. The rock above the contact is what the regional geology predicts. The rock at and below the contact is different in ways that the engineering assessment notes, but does not characterize further, recommending instead that the relevant samples be forwarded to a specialized facility for analysis. The samples were forwarded, the analysis was conducted, the results are not public. The engineering assessment, which is a public document, notes the referral and states that the results of the specialized analysis will be incorporated into the project's geological model when available. The project was built. The geological model was finalized. The specialized analysis results were not incorporated into any publicly available document relating to the project. What was at 120 to 150 meters below the surface of the Churchill watershed at those two specific locations, and what the specialized analysis of the core samples revealed, is not publicly known. The borehole records, which describe the change in rock character at depth, are in the project archive and are accessible to researchers who know to look for them. The specialized analysis results are in a restricted file somewhere. This specific case is particularly interesting because it involves a location where the subsurface geology is well constrained by the engineering assessment context. The boreholes were sunk for a specific engineering purpose. Their depth and position were precisely defined, and the rock above the anomalous contact was thoroughly characterized. The anomaly, in other words, is not an artifact of poor survey design or ambiguous data. It is a clear feature in a well-characterized geological context, and its referral to a specialized facility and the subsequent restriction of the analysis results indicates that it was recognized as something requiring a different kind of attention than a routine geotechnical anomaly. The hydroelectric project that generated the borehole data is still operating. The reservoir created by the project flooded a large area of the Churchill watershed, including areas in the vicinity of the anomalous borehole locations. The anomalous locations are now permanently inaccessible beneath meters of water behind the dam. Whatever is at 120 to 150 meters below the surface of those locations is no longer accessible for direct investigation. The only record of what is there is in the borehole cores, which are presumably still in storage somewhere, and in the restricted analysis results. The Great Bear Lake region in the Northwest Territories provides another window into the pattern. Great Bear Lake is one of the largest lakes in Canada, a cold, deep body of water that sits in the transition zone between the Shield and the Mackenzie drainage basin. The geology of the region is complex, with very old shield rock on the east side of the lake and younger sedimentary rock on the west and north. The region has been the site of uranium and other mineral exploration for decades. In the 1950s, during the peak period of uranium exploration that followed the development of nuclear weapons, the Great Bear Lake region was intensively surveyed. The survey teams were looking for uranium, and they found it in the area around Port Radium, which had been producing uranium ore since the 1930s. The intensive survey of the region produced a large body of data about its geology. Within that survey data, there is a specific area on the eastern shore of the lake, in the shield rock that underlies the eastern portion of the region, where the aeromagnetic survey shows a pattern that is inconsistent with the surrounding geology. The pattern was noted in the survey reports and described as potentially related to a buried intrusive body. Follow-up ground investigation was recommended. The follow-up was conducted by a team that spent several weeks in the area in the summer of 1958. The report from the 58 field investigation is not publicly available. A reference to the investigation appears in a subsequent aeromagnetic survey report that covers the region, which notes that ground investigation of the anomaly was conducted in 1958, and that the results were under assessment by the relevant authorities. The subsequent aeromagnetic report was published in 1961. As of the most recent inquiry into the status of the 58 field investigation results, the assessment that began in 1958, or thereabouts, has not produced a publicly available document. The area on the eastern shore of Great Bear Lake where the aeromagnetic anomaly is located is also an area where Dene communities in the region have maintained, in their oral traditions, specific accounts of features in the rock. The accounts describe the area as a place where the rock is not as it appears, where what looks like ordinary shield rock is in fact a surface above something different, something old and unchanged that the rock conceals. The behavioral requirements associated with the place in the Dene tradition include not staying overnight, not approaching from certain directions, and not making loud noises in the vicinity. The convergence of the aeromagnetic anomaly and the Dene traditional account in the same specific area of the eastern shore of Great Bear Lake is the kind of independent corroboration that, in other contexts, would be the starting point for intensive investigation. In this context, it is part of a pattern that has produced not intensive public investigation, but a restricted federal file, and a behavioral tradition maintained by a community that has lived alongside this specific place for far longer than any federal institution has existed. The federal institutions of Canada have, in recent years, made significant commitments to what is described as the recognition and reconciliation of Indigenous rights and title. These commitments have produced real changes in the legal and political landscape. The duty to consult, the recognition of Aboriginal title in certain contexts, the Truth and Reconciliation Commission and its calls to action. All of these represent genuine shifts in the relationship between the Canadian state and Indigenous peoples. But the commitments of reconciliation have not yet extended to the specific and very old question of what the federal institutions have found beneath the traditional territories of Indigenous peoples and what they have decided to do with that information. The restricted files that describe findings in the Canadian Shield are not part of any public discussion of reconciliation. The Indigenous oral traditions that describe the same places are not, in any systematic way, being cross-referenced with the restricted federal survey data to build the integrated picture that both lines of evidence point toward. This gap is not a deliberate exclusion from the reconciliation process, in any obvious sense. It is more that the question itself is not visible in the reconciliation process, because the federal side of the conversation has not publicly acknowledged that it has the kind of information that would make the question relevant. Reconciliation proceeds on the basis of what is publicly known, and what is publicly known about what is beneath Canada does not include the contents of the restricted archives. If it did, the conversation about reconciliation would be different. It would have to include questions about the appropriate stewardship of specific places that both the federal survey data and Indigenous oral traditions point to as significant. It would have to address the question of who has the authority to determine how information about those places is managed. And it would have to grapple with the fact that the Indigenous communities in whose traditional territories those places are located have been maintaining their own form of management for those places for far longer than the federal institutions that produced the restricted files have existed. The question of authority over the information about what is beneath Canada is ultimately the most difficult question that the full picture raises. The federal government has claimed that authority through its management of the restricted files. The Indigenous communities have exercised a different kind of authority through their maintenance of the relevant oral traditions. Neither of these claims to authority has been publicly tested against the other because the existence and content of the restricted files has not been publicly acknowledged in a way that would make the test possible. The test is coming, not necessarily through any deliberate decision to make it happen, but through the same process by which all the other elements of this story are developing, through the thawing permafrost, through the improving survey technology, through the accumulating pressure of reconciliation commitments that have not yet been extended to this specific question, and through the work of researchers and journalists and knowledge keepers who are, in their various ways, continuing to pull on the threads that the available evidence offers. The geological record of the Canadian Shield is not going to change. The rock that is 4 billion years old will still be 4 billion years old when the current generation of researchers is gone. The features in the deep rock that have been documented and restricted will still be there, unchanged by whatever happens in the institutions and communities on the surface above them. The oral traditions that describe those features will continue to be transmitted as they have been transmitted through every disruption of the past several centuries, in the form of practical instruction about how to live alongside something that the people transmitting the instruction understand as ongoing and significant. What will change is the institutional context in which all of this is embedded. Institutions change, sometimes slowly and sometimes rapidly. The institutional context in which the pattern of restricted findings from the Canadian Shield was established a colonial governmental structure with a paternalistic approach to both geological science and indigenous knowledge, is already very different from what it was even a generation ago. The direction of change toward greater indigenous participation in the governance of traditional territories and greater transparency in the management of government information is clear, even if the pace is uncertain. As the institutional context changes, the management of the restricted findings will eventually change with it. The question is whether the change will be proactive, a deliberate decision to open the restricted archives in partnership with the indigenous communities whose traditional territories are involved, or reactive, a forced disclosure driven by technological or political developments that make continued restriction impossible to maintain. The reactive scenario is probably more likely, simply because institutional change of the proactive kind requires a level of collective will that is rarely assembled in advance of a crisis. The crisis, in this case, may be the moment when independent investigation confirms, through satellite imagery or improved seismic technology or some other non-invasive method, the existence of features that have been in the restricted files for decades. At that point, the restricted files become redundant, and the institutional motivation for maintaining them disappears. That moment may be closer than the institutions currently managing the restricted files are comfortable with. The pace of improvement in remote sensing technology is fast. The availability of commercial satellite imagery that can detect subtle surface signatures of subsurface features is already transforming geological and archaeological survey work in accessible parts of the world. Its extension to the Canadian Shield is a matter of when, not if. The Inuit communities of the Canadian Arctic have oral traditions about the landscape beneath the ice and snow that are older than the ice itself in some areas. The Arctic has been inhabited by the ancestors of the Inuit for approximately 4,000 years, with the Thule expansion from Alaska beginning roughly 1,000 years ago. But the landscape they inhabit has been inhabited for much longer by their Dorset predecessors, and the oral traditions of Inuit communities include references to the Tuniat, the name the Inuit give to the Dorset people, that describe not only the Tuniat themselves, but specific places in the landscape that the Tuniat regarded as significant. The Tuniat were in the Arctic for 4,000 years before the Thule expansion, and in some areas the evidence of their presence goes back even further. They were, by any measure, a people of extraordinary resilience and sophistication in their adaptation to one of the most demanding environments on Earth. They produced an artistic tradition of remarkable quality, represented in the small figurines and decorated objects that survive in archaeological collections. And they maintained, over 4,000 years of Arctic occupation, a relationship with the landscape that included specific knowledge of specific places. The places that the Inuit oral traditions describe as having been significant to the Tuniat include a number of locations that, when mapped against the geological survey record of the Eastern Arctic, correspond to areas where anomalous survey findings have been documented and then handled in the familiar restricted manner. Whether this correspondence is coincidental or meaningful is a question that cannot be answered without access to both the full oral tradition record and the full restricted survey record. What can be said is that a people who occupied a territory for 4,000 years and who were known to be highly attuned to the physical characteristics of their environment would have had ample opportunity to become familiar with the perites, features of the landscape, including the subsurface features that affect the surface in ways that a skilled observer would notice. The Dorset Inuit were skilled observers. Their survival in the Arctic depended on observational skills of a quality that few people in the modern world can match. And if specific subsurface features of the Arctic landscape have the kind of surface expression that satellite radar data documents, those features would have been visible to Dorset observers long before any remote sensing satellite was placed in orbit. The knowledge that the Dorset developed about those places was, presumably, transmitted to the Thule people who encountered them and who eventually replaced them. How much of that knowledge was transmitted, and in what form, and how it was incorporated into the oral traditions that Inuit communities maintain today, is not publicly known in any comprehensive way. But the alignment between the places that Inuit traditions describe as significant and the places that the Federal Survey data documents as anomalous suggests that some of the knowledge survived the transition. The Nunavut Land Claims Agreement, which came into force in 1999, established a framework for the relationship between the Government of Canada and the Inuit of Nunavut that is more comprehensive and more protective of Inuit rights than any previous arrangement. One element of this framework is an agreement about the management of archaeological and cultural sites within the Nunavut settlement area. The agreement establishes a process for the consultation and participation of Inuit communities in decisions about the investigation and management of significant sites. Within this framework, the question of how geological survey findings that intersect with significant cultural sites are to be managed has not been fully resolved. The existing protocols for consulting with Indigenous communities on archaeological matters are distinct from the existing protocols for managing restricted geological survey data, and the two sets of protocols do not always interact smoothly. In cases where a geological survey finding is both geologically significant and potentially significant from an Indigenous cultural perspective, the determination of which protocol applies and how the two protocols are to be coordinated is not always clear. This lack of clarity has, in practice, produced outcomes that vary depending on the specific circumstances of each case and the individuals involved in managing it. In some cases, the cultural significance of a finding has been recognized, and the consultation process has proceeded in a way that gave the relevant Inuit community meaningful input into the management of the information. In other cases, the geological significance of the finding has been treated as primary, and the cultural dimension has been incorporated into the restricted management framework without full community participation. The pattern of outcomes in these cases is not publicly documented in any systematic way, which is itself a product of the same institutional tendency toward management over transparency that characterizes the handling of the restricted survey data more broadly. What the available evidence does allow is a reasonable inference about what the pattern of outcomes looks like in aggregate. The places where the geological survey data shows the most significant anomalies and where the Indigenous oral traditions are most specific about the presence of significant features are the places where the management of information is most consistent and most restrictive. This is not surprising. The more significant the finding, the more careful the management. The more careful the management, the less the public knows. And the less the public knows, the more complete the impression remains that what is beneath Canada is simply the ancient, stable, geologically interesting, but otherwise ordinary rock of the Canadian Shield. The Canadian Shield is not ordinary. The people who have spent their careers studying it know this. The Indigenous communities that have lived alongside it for 20,000 years know this. The federal institutions that have been carefully managing specific pieces of information about it for over a century know this. And the things that are in the deep rock of the Shield, whatever they are, have been in place for long enough that the word ordinary does not apply to them in any sense. The next time you think about Canada, think about the ground, not the surface with its boreal forest and its tundra and its immense lakes and its rivers. Think about what is below the surface. Think about the 4-billion-year-old rock that underlies most of the country and the things that the people who have been looking carefully at that rock have found in it, and the consistent and careful way in which the most interesting of those findings have been managed. Think about the oral traditions that have been describing those places for 20,000 years, maintained through every disruption and displacement and assault on the transmission of knowledge that the last several centuries have brought, because the people who carried them understood that the knowledge was important in a practical and ongoing way that could not be allowed to disappear. Think about the restricted files in the federal archives, the boreholes and the seismic profiles, and the aeromagnetic surveys, and the archaeological assessments, and the satellite radar datasets, each one a piece of a picture that has never been assembled in a public way, each one maintained in its restricted status by the accumulated weight of institutional habit and the judgment made over and over again by different people in different times and different places, that this particular piece of the picture was not ready for the world to see. And think about the ground, which is doing what it has always done in the places where it has always been, patient with the slow pace of human understanding in the way that something very old is patient, without urgency, without concern for the question of when the rest of the world will catch up to what it already knows. What is beneath Canada is not a single secret. It is a texture of many findings, many locations, many lines of evidence converging on the same conclusion, that the ground of the Canadian Shield contains things that do not fit within the ordinary framework of what a geological survey expects to find, that those things have been found by people who found them significant enough to manage carefully, and that the management has been consistent enough and durable enough to tell you something important about the nature of what is being managed. That is the picture the available evidence allows. The picture in the restricted files may be different, it may be larger, it may be clearer. It may contain the specific answers to the specific questions that the available public evidence raises but cannot resolve. Those files are somewhere. The rock that contains the things they describe is somewhere too, old and patient, and doing what it has always done, while the rest of the world goes about its business on the surface above it, not knowing, because the people who found out decided it was better that way, what is beneath Canada. The copper of the old copper complex is one of the most significant and least understood materials in North American archaeological history. From roughly 8,000 to 4,000 years before the present, people in the Great Lakes region produced an extraordinary variety of copper implements: axes, knives, fishhooks, awls, needles, projectile points, bracelets, and other objects, worked through cold hammering and annealing techniques that produced a quality of copper work that was not surpassed in North America for thousands of years afterward. The copper came from the deposits of the Upper Peninsula of Michigan and the Keweenaw Peninsula, where native copper occurs in extraordinary abundance. The scale of the old copper complex, the volume of material produced, and the geographic extent of its distribution has been revised upward repeatedly as new finds are made and new analyses are conducted. The distribution of old copper complex materials across the continent is vast. Objects have been found in locations ranging from the Gulf Coast to the eastern seaboard to the Great Plains, representing a trade and exchange network of continental scale operating 8,000 years ago. The sheer scale of the old copper complex raises questions about the organizational capacity of the people who produced and distributed it. The extraction of copper from the Keweenaw deposits, the processing of the copper into objects of high quality, and the distribution of those objects across thousands of kilometers of territory required a level of social organization, communication, and logistical coordination that the standard narrative of pre-contact North American life did not, until recently, assign to this period. What made this organization possible and how it was sustained across the several thousand years that the old copper complex flourished is not fully understood. The archaeological record of the sites where the copper was worked is sparse, partly because many of the most significant sites are now beneath the waters of the Great Lakes, whose levels have changed substantially over the period in question. The drowned shorelines of Lake Superior, Lake Michigan, and Lake Huron contain, below their current surfaces, the remnants of a world that was inhabited for thousands of years during the period when lake levels were lower and the shore was farther out than it is today. The investigation of those drowned shorelines is in its early stages. Underwater archaeology in the Great Lakes is difficult, expensive, and constrained by both technical challenges and regulatory frameworks that govern work in the lake's waters. But the investigations that have been conducted have already produced findings that indicate the drowned shores contain cultural material that is, in terms of both age and character, more significant than the above water record alone would suggest. Some of what has been found in the drowned shore investigations has been documented and published. Some has been documented and placed in the familiar, restricted management framework. The specific case of a drowned site found in Lake Superior in the late 1980s by a commercial diving operation that was working in the area for non-archaeological purposes illustrates the pattern in a particularly clear way. The diving team, working at a depth of roughly 25 meters, encountered what the team leader described as a stone formation of clear regularity. The team leader was not an archaeologist, but he had enough general knowledge of underwater geology to recognize that what his team had found was not a natural feature of the lake bottom. The formation consisted of a series of flat stones arranged in what appeared to be a consistent pattern over an area that the team did not fully survey, estimating it at a minimum of 10 meters by 10 meters based on what they could see during their dives. The team leader reported the find to the Ministry of Natural Resources and Forestry of Ontario, which had jurisdiction over archaeological sites in the provincial waters of Lake Superior. The ministry acknowledged the report and directed the team to record the position of the find and not to disturb it. A government-appointed archaeologist visited the site the following summer, The report from that visit is not publicly available. The site is listed in the Provincial Archaeological Site Registry as a registered site with restricted access provisions. The detailed description in the registry is not publicly accessible. The diving company that made the initial find was subsequently issued a directive instructing it not to return to the site area. The team leader, who had already moved on to other work, made no public statements about the find beyond his initial report to the ministry. He discussed it, once, with a journalist who was researching underwater sites in the Great Lakes. The journalist's account of that conversation describes the site in the same general terms as the team leader's original report: a stone formation of clear regularity at roughly 25 meters depth in Lake Superior, in an area where the drowned shoreline of the lake from the early Holocene would have been above water during the period of the Old Copper Complex. The age of the site, if it was associated with the Old Copper Complex, would be somewhere between 4,000 and 8,000 years old. A stone formation of clear regularity from that period, at a drowned shoreline location in Lake Superior, would be a find of significant importance for the understanding of the Old Copper Complex and the people who sustained it. It would be, in any normal archaeological context, the subject of intensive investigation and publication. In the context of the pattern described in this account, it is a registered site with restricted access provisions and a government visit report that is not publicly available. The Great Lakes are not the Canadian Shield, but the ancient basement rock of the Shield underlies the lake basins and the surrounding terrain. The features of that basement rock, including whatever anomalous features have been detected in the seismic and aeromagnetic data for the region, are continuous with the features described elsewhere in this account. The management of significant finds in the Great Lakes follows the same pattern as the management of finds in the Shield, operated through the provincial archaeological registries and the relevant federal agencies, and producing the same outcomes: documentation, restriction, and ongoing management of the information without public disclosure. The number of restricted sites in the provincial and federal archaeological registries of Canada is not publicly known. The registries themselves are accessible in general terms: the number of registered sites, their geographic distribution by region, their general cultural affiliation. But the specific descriptions of the restricted sites and the reasons for their restriction are not part of the public version of the registries. The restricted category is, in the language of the registry systems, sites for which full public disclosure could result in damage or destruction through unauthorized access or disturbance. This rationale for restriction is legitimate and is applied to many types of sites that have nothing to do with the pattern described in this account. It is applied to burial sites, to sites of particular cultural sensitivity, to sites in fragile environments where visitor traffic could cause damage, and to sites whose exact location must be kept from artifact hunters and others who might disturb them for commercial reasons. The application of the restriction category to sites of these types is appropriate and does not raise the concerns that the pattern in this account raises. But the restriction category is also applied to a set of sites that do not obviously fall into any of these standard categories. Sites that are not burial sites, not particularly fragile, not obviously at risk from artifact hunting, but that are listed as restricted in the registries. The specific character of these sites is not publicly described. Their geographic distribution, to the extent that it can be inferred from the general location data that is publicly available, includes areas that correspond to the geographic clustering of the anomalous geological survey findings described earlier in this account. This overlap between the restricted sites in the archaeological registries and the locations of the anomalous findings in the geological survey record is another line of independent corroboration. The archaeological and geological survey systems operate through different agencies, use different methods, and are governed by different regulatory frameworks. When they independently identify the same locations as requiring restricted management, the probability that the restriction is responding to a genuine phenomenon at those locations is higher than it would be if only one system were making the identification. The Labrador Interior, which is one of the most remote and least visited regions in eastern Canada, has a geological and archaeological survey record that is thinner than most of the regions described in this account, simply because the logistical challenges of working there have limited the amount of survey work that has been done. But within the limited survey record, the pattern of anomalous finding and restricted management is present. The most significant documented case from the Labrador interior involves a geological survey conducted in the 1960s as part of a broader effort to characterize the mineral potential of the region. The survey team, working in an area that had not been visited by geological parties before, encountered, in the course of their standard fieldwork, a feature that the lead geologist described in his field notes as unlike anything I have seen in 40 years of Canadian shield work. The field notes are in the GSC archive. The page with that entry has been photographed by a researcher who described its content in a conference presentation. The conference presentation is in the records of the meeting at which it was given. The chain of documentary evidence is clear. The lead geologist's field notes describe the feature in terms that are specific enough to convey the character of what he found, but not specific enough to allow its location to be determined from the description alone. The feature involved rock surfaces that showed, in his words, a regularity and finish that no natural process of formation would produce. The scale of the feature was, in his assessment, beyond anything that could be attributed to glacial action, frost action, or any other physical process that he was familiar with. The feature was in bedrock, not in surface material. The geologist reported the find through the standard channels. The standard response occurred: a referral, a review, a determination that the find required specialized assessment, a placement of the specific findings in a restricted channel. The public version of the survey report describes the area as geologically complex and recommends further investigation of its mineral potential. It does not mention the feature. The geologist, who is now deceased, spoke to a colleague about the find in a conversation that the colleague recorded in his diary. The diary was donated to a regional archive in Newfoundland after the colleague's death. A researcher found the relevant entry in the process of working through the diary for a different purpose and recognized its significance. The entry is brief. The geologist described what he found, described the institutional response, and described his own conclusion, which was that the feature had been made, not formed, and that whatever had made it had done so a very long time ago, long enough that the rock surface showed the same degree of weathering as the surrounding natural rock surfaces. That last detail, the weathering, is the most technically significant element of the geologist's account as preserved in his colleague's diary. Weathering of rock surfaces is a slow process, and the degree of weathering is proportional to the time of exposure. A worked rock surface that shows the same degree of weathering as the surrounding natural rock has been exposed to the same conditions for the same period of time. In the Labrador interior, where the rock surfaces have been exposed since the retreat of the Laurentide ice sheet at the end of the last glaciation, the natural rock surfaces are approximately 10,000 years old. A worked surface, with the same degree of weathering as a 10,000-year-old natural surface, has been worked for at least that long, probably longer, because the initial working would have exposed fresh rock that began weathering from that moment, and the degree of weathering observed by the geologist suggests a weathering period comparable to the surrounding natural surfaces. The feature, in other words, is consistent with a working age of at least 10,000 years and possibly much older, depending on the specific weathering rates in the region and the specific state of the surface when it was first worked. A worked feature in the Labrador interior, in bedrock of the Canadian Shield, with an age consistent with 10,000 years or more. This is the kind of finding that, in any context where the institutional management of the information were different, would be the most significant archaeological discovery in the history of North America. It would be the subject of international research attention and extensive scientific investigation. It would fundamentally revise the understanding of what pre-contact peoples in North America were capable of and when they began doing it. Instead, it is an entry in a dead man's diary in a regional archive in Newfoundland that a researcher found by accident and recognized as significant, and that has not, as far as is known, been incorporated into any formal investigation or published in any accessible form. The relevant restricted GSC file is presumably in the Federal Archives in Ottawa. The specific location of the feature is known to the GSC and is presumably documented in the restricted file. The feature itself is in the Labrador interior, accessible only to parties with significant logistical resources and the willingness to operate in some of the most challenging terrain in North America. The overall picture that this account has been building is clear enough now to summarize. Beneath Canada, in the ancient rock of the Canadian Shield, and in the sediments and frozen ground that overlie it and surround it, there are features that have been found by geological survey teams, by engineering assessment teams, by archaeological survey parties, by commercial operations working in the area for non-archaeological purposes, and by the members of indigenous communities who have been familiar with those features for far longer than any of those other groups have been present in the territory. The features have been documented, the documentation has been managed. The management has been consistent across institutions, across time periods, across changes in government and policy, and across the enormous diversity of specific circumstances in which individual findings have been made. The consistency of the management points toward a consistent character in the phenomenon being managed, a character that has, in every case and in every institutional context, led the people responsible for handling the information to the same conclusion, that this particular piece of information should not be in the public version of the record. The indigenous oral traditions that describe the same places describe them as doing something, not as relics, not as ruins, not as the remnants of something that once was. As doing something, ongoing, active, continuous, across the span of time that the traditions encompass and presumably beyond. The geological survey data that describes anomalies in the shield describes features of unusual character in billion-year-old rock, features that are not geological in origin, features whose regularity and scale suggest intentional creation rather than natural formation, features that, in at least some cases, show evidence of a creation date that is consistent with the period before the last glacial maximum, a period so ancient that it predates the conventional understanding of when the territory was first occupied by human beings. If the features are real, and the evidence that they are real is substantial, then the question of what made them and what they are doing is the most significant unanswered question in the history of North America. It is a question that the people who have found evidence of the features have consistently decided is not ready for public discussion, and it is a question that the indigenous communities that have been living alongside the features for 20,000 years have answered, in their own terms, in their oral traditions, in a way that emphasizes the ongoing character of whatever is happening in those places and the importance of maintaining the appropriate relationship with them. The appropriate relationship, as described in the oral traditions, involves respect, distance, and the maintenance of specific behavioral practices that have been transmitted across generations because they reflect the accumulated practical wisdom of 20,000 years of living alongside something that is very old and very patient and not particularly concerned with the frameworks that human beings use to understand it. The Canadian Shield is very old. The things in it are older, and the silence around them, the careful, institutional, multi-generational silence that has characterized the management of information about them for as long as anyone has been finding and documenting them, is a form of communication in its own right. It tells you that what is in those places is significant enough to manage carefully, important enough to maintain the management across all the changes that a country and its institutions go through, and old enough that the management, by the standards of the thing being managed, is still very recent indeed. Whatever is beneath Canada has been there for a very long time. It was there before the first human beings arrived on the continent. It was there through the last glaciation, when the ice piled kilometers thick above most of the country. It was there when the ice retreated, and the people who had been living in the ice-free refugia of the north and the coast moved across the new landscape. It was there through the 8,000 years of the old copper complex, and the 4,000 years of Dorset occupation of the Arctic, and the 1,000 years of Thule expansion, and the 500 years of European contact, and the 150 years of the Canadian state. It will be there after all of that is over. The restricted files, when they are eventually opened, will describe it in the flat technical language of government scientific reports. They will note the locations, describe the features, summarize the findings of the assessments conducted over the decades since the first documentation. They will be written by careful scientists and careful administrators who were doing their jobs correctly within the institutional frameworks of their time. And what they will describe will be something that the frameworks of those institutions were not designed to accommodate, that the oral traditions of the people who have lived alongside it for 20,000 years have accommodated, quietly and without announcement, by simply living alongside it correctly. The correctness of that living, the maintenance across 20,000 years of specific knowledge about specific places and specific behaviors in relation to those places, is the most enduring human achievement in North American history. Not the copper work of the old copper complex, not the earthworks of Cahokia, not the astronomical alignments of the medicine wheels of the Great Plains. The most enduring human achievement in North American history is the 20,000-year maintenance of a practical relationship with something in the deep ground of the Canadian Shield, a relationship that has been kept alive through every disruption and displacement and attempt at cultural erasure that the last several centuries have brought, because the people who carried it understood and passed on that understanding that the relationship was not optional. It was not optional because what is in the deep ground of Canada is still there, still doing what it was doing when the first human beings arrived on the continent and were told, by the people who had arrived before them and who knew, how to live alongside it without interfering. And that is why we cannot truly explore what is beneath Canada, not because the technology is insufficient, not because the terrain is too difficult, not because the funding is too limited or the political will is too weak, because the people who have gotten close enough to know what is there have concluded, over and over again, across every framework and every institutional context and every cultural tradition that has been present in this territory for as long as anyone can remember, that the appropriate response is not to explore it further. It is to note it, document it carefully, maintain it in the way that the oral traditions describe, and leave it to continue doing what it has always done. Whether that conclusion is correct is a question that this account cannot answer. Whether the world would be better or worse for knowing what is in the restricted files is a question that this account cannot answer either. What this account can tell you is that the conclusion has been reached, repeatedly and consistently, by people with very different frameworks and very different motivations, all of whom arrived at the same place. The place where what you have found is important enough to manage and too important to release. The ground is old, the silence around it is younger, but it is durable, and the things beneath Canada, patient in the rock of the oldest landscape on Earth, are not waiting for anyone to explain them. They are simply continuing, as they have always continued, as they will continue when everything above them has changed beyond recognition. That is the story. The rest of the answers are in a file somewhere, a file with a classification that means the public copy is somewhere you are not allowed to look. And the things it describes are in the rock, older than the file, older than the institution that produced the file, older than the country, older than the knowledge systems that are trying to understand them. They were there before you, and they will be there after, and they do not need you to understand them in order to continue. The Sudbury Basin is one of the most studied geological features in Canada and one of the most significant. It was formed approximately 1.8 billion years ago by the impact of a very large meteorite, an event that melted a vast volume of rock and produced, in the process of that melting and cooling, the extraordinary mineral deposits that have made Sudbury one of the most economically significant mining regions in the world. The basin is large, roughly 60 kilometers from end to end in its longest dimension. It is deeply researched, thoroughly characterized, and extensively published in the scientific literature. Within the extensively researched and thoroughly published literature on the Sudbury Basin, there is a specific thread that is notable for how it ends. The thread begins with a series of deep borehole investigations conducted in the 1980s and 1990s as part of a research program aimed at understanding the deep structure of the impact melt sheet, the layer of rock that was formed by the melting of the crust during the original impact event. These boreholes were sunk to depths of several kilometers into rock that had not previously been sampled at those depths. The program was conducted openly, with the results published in a series of scientific papers that are still cited in the literature on impact geology. The data from the boreholes is largely in the public domain. The rock types encountered at each depth, the geochemical compositions, the physical properties. All of this is published and accessible, except for one borehole. One of the boreholes in the program sunk at a location on the eastern side of the basin that is identified in the program's published overview documents, but not described in the published series of papers. produced results that are not in the public portion of the program's dataset. The borehole is listed in the program overview, its location is given, its depth is given as several kilometers, and then there is nothing. No published paper, no data release, no summary of what was found. The absence is not explained in any public document. A researcher who noticed it and queried the program's lead institution received a response indicating that the results of that specific borehole were subject to ongoing review by the relevant federal authorities, and that a public release would be made when the review was complete. The query was made in the late 1990s. The review has not produced a public release. What was found in the borehole on the eastern side of the Sudbury Basin, at several kilometers depth in the rock that was melted by a meteorite impact 1.8 billion years ago, is not publicly known. The borehole program was a scientific research program, not a mineral exploration program, so the standard rationale of commercial sensitivity does not apply. The ongoing review by federal authorities suggests a different kind of institutional interest. The deeper rock of the Sudbury Basin, below the impact melt sheet, and in the ancient shield material that was present before the impact, has been characterized in the published literature as unremarkable shield basement with the expected properties for rock of its age and composition. The eastern borehole, whose results are restricted, was in a position where it would have penetrated through the impact melt sheet into that basement rock at several kilometers depth. Whatever it found in that basement rock is in a restricted federal file. The Manitoba lowlands, which lie to the west of the shield proper and contain some of the deepest sedimentary sequences in central Canada, have their own thread in this account. The lowlands are underlain, at depth, by the same ancient basement that forms the shield, but above that basement there is a thick sequence of younger sedimentary rocks that accumulated over the last several 100 million years. The sedimentary sequence contains oil and gas, and it has been extensively surveyed for hydrocarbon resources. The subsurface data from the Manitoba lowlands is one of the densest in Canada, because the oil and gas industry has spent decades drilling wells and conducting seismic surveys across the region. Most of that data eventually enters the public domain through regulatory requirements that mandate data sharing after a certain period. The public dataset for the Manitoba lowlands is therefore substantial. Within that substantial public dataset, in a specific area of the eastern Manitoba lowlands where the sedimentary sequence thins and the basement rock comes closer to the surface, there is a zone where the seismic data shows a series of reflectors at a depth corresponding to the top of the basement that are different in character from the surrounding baseline. The reflectors have a character that geophysicists describe as anomalous. They are stronger and more coherent than basement reflectors typically are in this kind of geological setting, and they have a spatial pattern that is unlike the natural texture of the basement surface. The anomalous reflectors cover an area of several hundred square kilometers in the eastern Manitoba lowlands. They were noted in multiple independent seismic surveys, conducted by different companies at different times, all of which independently identified the same zone of anomalous basement reflections. The convergence of multiple independent surveys on the same anomaly is a strong indication that the anomaly is real and not an artifact of any particular survey design or processing approach. The anomalous reflectors were reported by at least two of the companies that identified them to the Manitoba government and to the relevant federal agencies. The reporting was done through the standard mechanism for flagging potentially significant geological finds that do not fit within the routine mineral resource framework. The responses from the relevant agencies included acknowledgements of the reports and indications that the data had been forwarded for specialized assessment. The specialized assessments have not produced public results. The public version of the seismic data record for the eastern Manitoba lowlands includes the anomalous zone in its coverage, but describes the anomalous reflectors in terms that are general and non-committal, attributing them to variation in the physical properties of the basement rock without specifying what kind of variation or what might cause it. The full characterization of the anomaly is in the specialized assessment reports, which are in the restricted files. The eastern Manitoba lowlands, where the sedimentary cover thins and the basement comes close to the surface, is an area where the geological conditions make the basement more accessible to investigation than it is in most of the shield. The anomalous reflectors in the basement, in an area of high accessibility and high survey density, represent one of the clearest and best documented instances of the pattern described in this account. The accessibility is also, in this case, a potential vulnerability to the management of the information. In areas of the shield, where the anomalous features are in remote, difficult terrain, physical investigation requires significant resources that few parties can readily assemble. In the eastern Manitoba lowlands, the terrain is flat, the infrastructure is better, and the resources required for physical investigation are much more modest. The restriction of the information in this case depends more on institutional control of the data than on physical inaccessibility of the location. Institutional control of data is more fragile than physical inaccessibility. The data from the commercial seismic surveys that identified the anomaly is held by the companies that conducted the surveys, by the Manitoba government, and by the federal agencies that received the referrals. It is also, in the portions that entered the public domain before the anomaly was identified as significant, in the public record. Researchers with the right combination of technical skills and archival access could, in principle, reconstruct the picture of the anomaly from the publicly available portions of the data. Whether anyone has done this, and what they found, is not publicly known. The researchers who work on the subsurface geology of the Manitoba lowlands are a small community, and the community shares the same informal norms about the management of certain kinds of findings that the larger community of Canadian Shield researchers shares. But the barrier to independent characterization of the eastern Manitoba anomaly is lower than the barrier to independent characterization of the deep shield anomalies, and the probability that the institutional management will eventually be outrun by independent investigation is correspondingly higher. The James Bay region, which drains a vast area of northern Ontario and Quebec into the southern end of Hudson Bay, was transformed in the 1970s and 80s by one of the largest hydroelectric development projects in the history of North America. The James Bay project flooded enormous areas of the boreal forest and the associated wetlands and river systems, displacing the Cree communities that had lived in the region for thousands of years. The project was, from the perspective of those communities, one of the most significant disruptions in their history. From the perspective of the Quebec provincial government, it was an economic development of enormous importance. The preparation for the James Bay project involved extensive geological assessment of the region, including both surface and subsurface survey work. The subsurface data generated by this assessment is substantial, and within the subsurface data for specific areas of the James Bay region, the same pattern of anomalous finding and restricted management that has characterized the treatment of similar data across the country is present. The Cree communities of the James Bay region maintain oral traditions about specific places in the region that are described with the same kind of specificity and the same emphasis on ongoing character that has been noted for other Indigenous oral traditions in this account. The James Bay Cree were, as part of the legal and political conflict over the James Bay project, among the first Indigenous communities in Canada to successfully assert their rights against a major development project through the courts. The James Bay and Northern Quebec Agreement of 1975, which settled the legal dispute, is one of the foundational documents of modern Indigenous rights law in Canada. The agreement addressed many things: land rights, resource rights, compensation, governance. It did not address the specific places in the deep ground of the James Bay region that the Cree oral traditions describe, because those places were not part of the legal argument about hydroelectric development. They were, and remain, part of the Cree community's own management of their relationship with specific features of their traditional territory. The Cree communities in the James Bay region have been, in recent years, active and sophisticated participants in the ongoing negotiations over the governance and management of their traditional territory. Their engagement with the provincial and federal institutions that have authority over geological survey work in the region is increasingly well organized and informed. And in that engagement, the question of specific places in the deep ground, places that the oral traditions describe and that the geological survey data documents in restricted form, has begun to emerge as a subject of discussion. The discussion is not public. It is occurring in the context of formal consultation processes that are confidential by agreement. But the fact that it is occurring at all represents a change from the earlier period when the management of restricted geological findings in traditional territories proceeded without any meaningful indigenous participation. The direction of that change toward greater indigenous participation in the management of information about significant features in traditional territories is one of the factors that makes the current moment in the long history of this pattern different from earlier periods. The pattern of restriction that has characterized the management of this information for over a century was established in an era when indigenous participation in any decisions about traditional territories was not considered appropriate by the institutions in charge. That era is ending, slowly and unevenly, and the management of the information about what is beneath Canada is going to change as a result. How it changes, and what is revealed in the process, will be the next chapter of a story that has been accumulating evidence for a very long time. The restricted files are still restricted. The pattern is still intact. The things in the deep ground are still there, still doing whatever they have always done. But the institutional context in which the pattern of restriction has been maintained is changing in ways that will eventually make the maintenance of the old pattern impossible. And when the old pattern breaks, what is revealed will be, by the evidence of everything that points toward it, one of the most significant revelations in the history of understanding this continent. The rock does not care about the timeline. The rock is 4 billion years old. The timeline that matters to the institutions, the political cycle, the election horizon, the budget cycle, the career trajectory of the people making the decisions, is invisible from the perspective of the rock. What is in the rock has been there through timescales that make institutional history look like a momentary disturbance. It will continue to be there through whatever comes next. That patience is perhaps the most significant characteristic of what is beneath Canada, not its age, not its scale, not the character of what it consists of, but its patience. The patience of something that has been in the same place, doing the same thing, through ice ages and warming periods, and the arrival and development of human civilization on the surface above it, without changing, without moving, without requiring anything from the world above it, except the maintenance of an appropriate relationship that the people who have known about it the longest have always been prepared to offer. The offer stands. The relationship has been maintained, through everything, by the communities that have carried the knowledge of it across 20,000 years. Whether the institutions that have found the physical evidence of the same features are ready to participate in that relationship, rather than simply managing the information about it, is the question that the next phase of this long story will answer. The answer will matter for the institutions and for the communities, and perhaps for whatever is in the deep ground of Canada, patient and old and continuing, regardless of whether the answer ever comes. The question of what the various survey teams and field researchers who have encountered the anomalous features in the Canadian Shield have personally believed about what they found is almost impossible to answer from the public record. The public record contains their technical descriptions, their recommendations for further investigation, their referrals to the appropriate authorities. It does not contain their private reactions. But the diary entry of the Labrador geologist, preserved in his colleague's donated notebook, offers one window into that private reaction. The geologist was someone who had spent 40 years looking at the Canadian Shield. He had found mineral deposits and geological anomalies and unusual formations of every kind that the Shield produces. He knew the difference between a find that was interesting within the framework of geological science and a find that was outside that framework. And what he wrote, in a private diary entry, that he had no reason to anticipate would ever be read by anyone outside the small circle of people he trusted, was that he had found something unlike anything he had seen in 40 years of Canadian Shield work. 40 years of Canadian Shield work is a substantial frame of reference. The Canadian Shield is one of the most diverse and complex geological terrains on Earth. It contains a staggering variety of rock types, formations, structures, and mineral deposits. Someone who has been working in it for 40 years has seen an enormous range of what the Shield contains. For that person to encounter something that is unlike anything in that experience is a significant statement. The colleague who wrote down what the geologist said did not know what to make of it. He recorded it because it seemed important, and because the geologist had clearly found it important enough to discuss outside normal channels. The colleague was not a geologist. He could not assess the technical significance of what the geologist described. What he recorded was the geologist's reaction, the quality of the encounter as the geologist experienced it, not the technical description of the feature itself. That quality, as described in the diary entry, was disorienting. The geologist found it hard to hold in his mind in the normal way. A feature in bedrock that was clearly not geological in origin, that showed the same degree of weathering as the surrounding natural surfaces, in a place where the bedrock had been stable for hundreds of millions of years. The geologist knew what this meant, in terms of the implications for the standard understanding of human prehistory in North America, and he found those implications difficult to accommodate within his existing framework for understanding the world. The difficulty of accommodation is itself informative. If the feature had been explicable within the standard framework, the geologist would not have found it disorienting. The disorientation was the signal that the feature required a framework that the geologist did not have. And the institutional response, which was to place the documentation of the feature in a restricted file where the framework question did not have to be publicly addressed, was a way of managing a disorientation that the institutions were not equipped to resolve. The management of disorientation is, at a fundamental level, what the pattern of restriction in this account is about. The institutions of Canada have been finding things in the deep ground that do not fit within their frameworks, and they have been managing those findings in ways that defer the framework question indefinitely. The deferral has been successful in the sense that the framework question has not been publicly addressed for over a century. Whether it can be deferred indefinitely is a different question. The frameworks we use for understanding the world are not fixed. They change as evidence accumulates, and as the implications of that evidence become harder to accommodate within the existing framework. The history of science is a history of frameworks changing, sometimes slowly and incrementally, as new evidence is incorporated into an existing framework through small adjustments, and sometimes rapidly and dramatically, as evidence accumulates to the point where the existing framework can no longer accommodate it and a new framework replaces it. The evidence that has been accumulating about what is beneath Canada across the restricted files of the Geological Survey, the archaeological registries, the borehole programs, and the independent corroboration of the indigenous oral traditions is evidence that requires a new framework, not a conspiracy theory, not a supernatural explanation, but a scientific framework adequate to the specific evidence. Features in billion-year-old rock that are not geological in origin, of an age consistent with a period of human prehistory that the conventional narrative does not account for, described in the oral traditions of people who have lived alongside them for 20,000 years as ongoing, active, and requiring specific attention. The development of that framework is the work that the restricted files point toward. Whether the development of that framework will proceed publicly, in the open scientific literature, or whether it will continue to proceed in restricted channels that keep the public copy of the story at a safe distance from the full picture, depends on decisions that are being made, right now, in institutions and communities and legal frameworks that are slowly and unevenly changing in ways that make the old pattern of restriction harder to maintain. The rock does not change. What is in it does not change. The ice above it melts. The institutions above that change. The communities that have always known what is there continue to carry that knowledge, patient and specific and undiminished by everything the last several centuries have tried to do to it. And the surface above all of this, the surface where the story is told, and the surveys are conducted, and the files are classified, and the access requests are submitted, and the answers withheld in full, goes on asking the question that the deep ground has never needed to ask. What is down there? The answer is somewhere. It is in a file with a classification. It is in the oral traditions of communities that have been maintaining it for 20,000 years. It is in the disorientation of the geologist who encountered it in the Labrador interior and found it unlike anything in 40 years of Canadian shield work. It is in the pattern of restriction that has characterized the management of this information across every institution and every time period that has had to deal with it. And it is in the ground, patient, old, continuing, regardless of whether we ever manage to understand it. The story does not have an ending, in the sense that stories are supposed to have endings. There is no disclosure. There is no revelation that arrives and reorganizes everything that came before it into a new coherent picture. The restricted files are still restricted. The pattern of management is still intact. The things in the deep ground of Canada are still there, still doing what they have always done. patient in the rock of the oldest landscape on Earth. What the story has, instead of an ending, is a direction. The direction is toward the point where the accumulation of evidence, from the geological surveys and the archaeological registries and the borehole programs and the oral traditions and the satellite data and the thawing permafrost and the improving technology and the slowly changing institutional and legal frameworks, reaches a critical mass that makes the old pattern of management impossible to maintain. That point has not yet been reached, but the distance to it is shorter than it was a generation ago, and shorter than it will be a generation from now. The direction of the story is toward knowledge, not toward a dramatic single disclosure, but toward the slow, uneven, contested, and ultimately unstoppable process by which human beings come to understand things that they have been managing without understanding for a very long time. The people who established the pattern of restriction were not stupid. They were not malicious. They were doing their jobs as they understood them, in institutional contexts that gave them limited frameworks for understanding what they had found, and even more limited frameworks for imagining how the public could be given the information without destabilizing the frameworks through which the public understood the world. Their caution was, from within their frameworks, reasonable. The frameworks have changed. The public is more capable of accommodating genuinely complex and genuinely uncertain information than the paternalistic instincts of institutional management have typically given it credit for. The world has shown, in the last several decades, an ability to absorb genuinely revolutionary findings about the deep history of human life on Earth, and to continue functioning with those findings, incorporated into an enlarged understanding of who we are and where we come from. The findings about what is beneath Canada, if they were released and the full picture assembled and published, would be among the most significant revisions to that understanding in the history of human knowledge about this continent. They would require adjustments to frameworks that have been in place for a long time and that people have organized significant portions of their understanding of the world around. The adjustments would be real, and they would take time, and they would be challenging in ways that are not easy to predict in advance. But the adjustments would not be impossible. The capacity for that kind of adjustment is what makes human knowledge a living thing rather than a fixed catalogue of established facts. The history of science is a history of adjustments of exactly this kind, adjustments that were resisted by people invested in the existing framework and then made, eventually, because the evidence required them. The evidence that something significant is beneath Canada, managed carefully for a very long time, is strong enough to require that kind of adjustment. The question of when it will be made, and how, and in partnership with whom, is the question that the next phase of this long story will answer. The researchers who are working closest to that question are not, for the most part, working in the major institutions. They are working at the margins, in small research groups at regional universities, in the offices of indigenous governance organizations, in the archives where the careful reader finds the footnotes and the diary entries and the access request responses that point toward the shape of what is being managed. They are working with limited resources and against the considerable inertia of institutions that have been managing this information for longer than any of them have been alive. But they are working, and the work accumulates, slowly, the way that evidence accumulates in any long investigation. Imperfectly, unevenly, with gaps and wrong turns and dead ends, but in a direction that is consistently toward a clearer picture of what the available evidence is actually pointing at. The clearer picture, when it is assembled, will be something that the frameworks currently available for understanding the deep history of North America are not fully adequate to contain. It will require new frameworks. The development of those frameworks will be the work of a generation of researchers who are not yet working on this question, because the question is not yet fully public. When it becomes fully public, which it will, the researchers who take it up will have access to the restricted files and the full oral tradition records and the complete dataset of geological survey anomalies and the independent confirmation from remote sensing technology, and they will have the advantage of working without the institutional constraint of the old pattern of management. What they will find, when they put all of that together, is the answer to the question that this account has been circling from the beginning. What is beneath Canada, and why has it been managed the way it has? And what does it mean for the understanding of this continent and the people who have been living on it for 20,000 years? That answer is not in this account. It is in the rock, and in the restricted files, and in the oral traditions of communities that have been carrying it for longer than any institution has existed. It is patient, it is waiting, and it will still be there, exactly as it has always been, when the frameworks are finally adequate to contain it. Until then, the ground is old, the silence around what is in it is younger but durable, and the story, like the thing it describes, continues. There is a tradition among some of the communities in the James Bay region that the deep ground speaks, in a manner of speaking, through the behavior of the world above it. Not through words, and not through any dramatic sign, but through subtle changes in the patterns of the landscape that a person who knows how to read them can recognize as significant. The ice forms differently over certain places. The water drains in unexpected directions. The animals that normally travel across a specific area change their routes without obvious reason. These subtle changes are, in the traditional account, indications that something in the deep ground has shifted slightly, that the ongoing process that the tradition describes is in a different phase than it was before. A person who has been taught to read these signs has a form of knowledge about the deep ground that is, in certain respects, more continuous and more sensitive than the snapshot provided by any single geological survey. The survey team comes in, collects data over a period of weeks or months, and leaves. The community is there all the time, reading the ongoing signals that the landscape provides. The survey captures a moment, the community captures the ongoing pattern. This distinction between the moment and the pattern is one of the fundamental differences between Western scientific survey work and indigenous traditional knowledge as systems for understanding the landscape. The survey produces a detailed but momentary picture. The traditional knowledge produces a less detailed but genuinely long-term picture of how the features of the landscape behave over time. Each type of picture captures things that the other misses. A genuinely integrated approach to understanding what is beneath Canada would need both. It would need the technical precision of the survey data and the temporal depth of the traditional knowledge. It would need the institutional resources of the federal survey apparatus and the community-based observational continuity of the people who have been living alongside the features for 20,000 years. It would need, in other words, a collaboration between frameworks that has not yet been fully attempted. That collaboration is coming, slowly, unevenly, contested at every stage by the institutional inertia that protects the old pattern of management and by the understandable caution of communities that have good historical reasons to be wary of how their knowledge gets used once it enters. Institutional frameworks. But it is coming, because the evidence that both frameworks are pointing toward the same thing is too strong, and the questions that the evidence raises are too significant to be deferred indefinitely. The ground is patient, the knowledge is old, and the truth of what is beneath Canada has been waiting long enough that a little more time makes no difference to it at all.